in this example. And if we jump back to today's BPF, it's a bit more complicated now, but essentially the idea is still very similar. This is like all the different pruning point situations. So like, this is for jumps. Basically what I explained just before is on the right. You have like the conditional branch pruning point on the branch side and then on the landing side. And on the left, you have like the unconditional branch with only the pruning point on the landing side. But you have like a bit more situation, for example, with function calls. We don't need to go into details here. It's just like all the different cases that we could identify. And on the left, you can see the most basic one, which is when you are calling any helper. It should look like this. Basically, you have the pruning point just on the instruction next to the call. But then you have like more complicated situation like BPF to BPF call, in which you have like more pruning points. So to verify, we basically realized this by reading the code, and we wanted to verify that with real life progs. So we wrote like a little patch with Paul. So the idea here is to reuse a print of the live registers that was introduced recently. And we added like the thing that you could see in red here. So Paul will try to explain what you could see on the left next. So just focus on the red part for now. The idea here is that with a bit more realistic program, you can see like the pruning point in action. Basically on instruction 6, you have a call to a helper, like a map lookup. And you can see on the instruction just after, you have like this pruning point. And in instruction 8, where you had like this conditional branch, it's like the example I showed before. You have like the pruning point on the branch itself and at the landing side. So 8 plus 6 plus 1 equals 15. You have like the pruning point here. And then you have like this more complicated situation with the BPF to BPF call, like call to PC plus 5, pruning point here, pruning point on the next instruction, and pruning point at the landing side at 17. So yeah, hopefully with this little addition, it's easier to identify where the pruning points are in your real life progress. So getting back to our example, we have those two pruning points, as I said before. So let's see how it works when we are doing the state pruning. The state pruning will happen when we actually verify the program with the doCheck function. And we will, again, like simulate the execution of the prog. So first off, we'll start with 1, we'll simulate 1, and then we'll arrive on 2. And on 2, what will happen are two things. First, we will save the states, because since it's a pruning point, we trigger the pruning point logic, we save the state. And then for later analyzing the opposite path, we'll like push the alternative branch path to the stack for later verification. And so we'll continue through the branch. So we'll simulate 3, and we'll simulate 4. Arriving on 4, again, it's a pruning point. State pruning logic is triggered, and the state is saved. And then we'll simulate 5, arrive on 6. And on 6, because it's like the end of this particular exploration, we pop the second branch and restart from 4, pretty much. So we restart from 4 with the states that we save from 2. And again, since instruction 4 is a pruning point, it will trigger the pruning point logic. And now what we will check is if the previous state that we saved in the flow that is represented on the left is the same as the state is equivalent as the state on the state flow that we saved on the control flow on the right. If those are equivalent, we can stop here and we can stop like the verification process. So essentially the idea is that if the states are equivalent, we can just prove the flow without the additional cost of
Oh, is that this? Okay. This is another box where you go parts. That's like all. So you add it. Right. Oh, yeah. It's like saying yeah.
You saw that add your Google filter.
I did not see that. No. So, what's that?
Well,
Steven?
But he's retiring anyway, right?
why? He was going to retire sometime.
It happens.
No, if you click on the, your presentation should be uploaded to DUD, and you just select your presentation when you're ready to go. I have to do that previously since it's but basically. Yeah, just click the plus.
Yep.
And your presentation should be there.
Okay, I did have some last minute changes, so
So we can re-upload it.
Okay.
So is it uploaded to?
It's on the website. Yes.
Okay, so. That's right there. So it's the second one?
Yeah. I mean, the first one is the Google Docs link that will also work.
Okay. So we download. Okay. Go here. Manage upload presentations. This one here. And it has to take the PDF file, load them up into image files.
Got it.
Excellent. Okay, so
if I
Yep.
try it, it should work, but people will be able to see this on the stream, right?
yeah, so you can switch it back to default.
But,
Oh wait, is that the new one or the old one? Because we uploaded, but the old one's still uploaded as well.
yeah, so the
Yeah,
Dash
dash
one
one is the one you want. Yeah.
Yep.
Okay. Yep.
okay. Good.
Yeah.
Yeah, still a little time.
10 minutes still. So.
Good. Yeah, but wasn't sure if that
You didn't know if I didn't need my car.
Yeah. No, just it's the podium. Yeah, it's like airline compliance, as long as you have to be, and like some of the airlines now say it has to be under the seat and not in the overhead. Yeah. But then what I'll do is like at lunch, listen to charges with that. So I just, our deck or plug in. Yeah, later on, talking to. Yeah, I just thought I would mention.
Okay.
Yes.
See it. Good. Sorry, my hands are a little wet. From the bathroom. It's from the bathroom.
Yeah, so, yeah, it's, so this is a lot, so you want to go out there. Yeah, I mean, they're not gonna see it remotely, right, that's the problem. Right, you know, if you want people are attending, and so. Yeah, you can see, well, I mean, it's possible, but you have to. You have to like bring your laptop up and you have to join the meeting session and you have to take the presentation mode on your laptop. And then you have to like switch back into you know,
Good flight. Good flight. Here's my name card, and we will definitely be in a fight.
All right, why don't we get started, and I'll just let Arnd introduce himself. Yeah.
Hi, thank you all for coming. My name is Arnd. For those who don't know me, I'm okay. My name is Arnd. I work on ARM SoCs and across architectures, and I'm doing a follow-up to a talk that I did at the Embedded Linux conference in Amsterdam, where I talked about 32-bit architectures and the possible timeline of how long we'll have to maintain certain 32-bit architectures. And there was a lot of feedback that I asked for about who's actually using HiMem systems. So I'm going to talk specifically about HiMem and what kind of challenges we have there. So very brief recap, HiMem is what we use only on 32-bit systems if you want to have more than 3/4 of a gigabyte of RAM, oversimplified. You can use up to 16 gigabytes on 32-bit ARM, but almost nobody does. And the wide agreement is that HiMem has to die at some point in the future. The question is when and how. So I'll try to summarize the feedback that I got after the Embedded Linux conference talk, like what systems are still around and why do they use it. And then I hope that we can come to some conclusions and get a feeling like we have a lot of people in the room who have opinions on this, and maybe we can have some decisions for how we can proceed here. For everybody who doesn't remember 32-bit, either because they are too young to have used them before they got into kernel development, or because they've forgotten everything, understandably, the three main architectures that I'm worried about all use the same setup, where we have low addresses, up to 3 gigabytes of user space, process memory. Then we have the linear map in the kernel for low memory, where the first 768 megabytes up to 3 gigabytes are mapped one-to-one into the virtual address space, as we do on 64-bit. And then we have a little bit of VMalloc space, and all the other memory that does not fit in the linear map, that is HiMem. And depending on how we configure the kernel, we may have more user address space or more linear map. The default option on all three architectures in this list is to only have 168 megabytes. If you have 2 gigabytes of RAM, the natural choice would be to have the VM split 2 gig opt setting on x86, and we can do the same thing on a different name on PowerPC. We cannot currently do this on ARM, where the user space would be limited to under 2 gigabytes of RAM. This would completely avoid the HiMem problem, but it has other problems. There are two motivations that I've heard in favor of removing HiMem altogether. On the side of embedded developers, the existence of HiMem means that things break if they actually use it. So if you upgrade a kernel and you rely on HiMem, things may break because device drivers get it wrong, because nobody else is using HiMem. Stuff breaks. If you still plan to update a 32-bit ARM system for another 10 years, things will break. The other part is, as long as HiMem exists, there is a lot more pressure on removing support for 32-bit altogether, which I really hope we won't do anytime soon. But if we remove HiMem at some point, 32-bit gets less in the way of everybody else. From the perspective of memory management maintainers, removing HiMem would be a great simplification, and we certainly do not want to have HiMem on 64-bit systems ever. So removing it now is an investment in the future. Then there's equally motivations for keeping HiMem. People who use it today obviously don't want to change much, because the systems that use HiMem, that rely on HiMem today, are legacy systems. We only maintain them because we have customers using them and they require kernel updates. So doing any change is extra work that somebody has to pay for. And changing the VM split has the risk of breaking existing user space. And if you have a lot of memory, getting rid of HiMem just means your system might not be able to do what it's built for at all. Like if you have 6 gigabytes of RAM and you need 3 gigabytes of virtual address space in user space, without HiMem, the system is dead. You have to replace the hardware, which is very costly. So this is the basic conflict we have to resolve. So with these two sides. This is a completely made up graph showing my view of the system. I have a pretty good idea of what's going on because I get all the board files for newly added systems on 32-bit ARM, which is 95% of 32-bit today. Most of the new systems have either half a gigabyte or 1 gigabyte when people are building new systems, because the only reason to use 32-bit in new machines is when you're very cost sensitive and you want to save every penny. So you can't afford to put more than 2 memory chips in the system. One memory chip, you would have DDR3 typically. That's a 4 gigabit chip, which means half a gigabyte of RAM if you have 1 chip, 1 gigabyte if you have 2 chips. Those are the 2 normal options. Everything that has more than 1 gigabyte is probably already an older system. Some of those are still in production. 2 gigabytes used to be a common option on the higher end ARM 32-bit systems, but most of these have been replaced with 64-bit in newer designs. And the 4 gigabytes were never widespread, but there are systems that have 4 gigabytes or more that are in the field that are still getting upgrades. Looking at the smaller sizes, as I said, 1 gigabyte, still very common. People are building those, people are putting those into production. There's a problem. Some of these systems with 1 gigabyte have a discontiguous physical memory layout, where even though you have 1 gigabyte physical memory, and you might set the VM split 3 gig option to allow 1 gigabyte of low mem, it's still not mapped into low mem because it doesn't fit in the linear map. So those systems would still use HiMem, and we have a couple of SoCs that are built like this. Most SoCs have the memory linearly in the physical address space. And just changing from VM split 3 gig to VM split 3 gig opt to extend the 768 megabytes to 1024 megabytes of low mem may still break a small number of applications. So most applications wouldn't care. Some applications tightly control where things are mapped into user space addresses. And anybody using such an application may have to do user space changes, which again is expensive. The 2 GB case, what I said during my ELC talk is that they are becoming rare, but enough people have talked to me about those systems that I think we have to maintain them for as long as the 1 GB systems. Question is whether we can get enough of those to move over to a 2 gig VM split, that we can eventually remove high mem, or whether we have to find other workarounds for those systems. And besides ARM, I did hear back from several people using PowerPC systems, usually 15 years old, with 2 GB of RAM. Question.
I'm just wondering, because like the topic of like old systems where we ship upstream kernels comes up every now and then, like Spark 64, for example, where we still maintain upstream kernels. I was wondering, like, when you say that running stuff in production, does that mean that we actually have to support the upstream kernel, latest, greatest on these systems, or could we just at some point say, well, you keep your LTS kernel, you run your old workloads, we're going to deprecate it upstream, we're going to remove it upstream, but you don't have to run the latest, greatest upstream kernel on these old systems anymore. Is there a way forward?
Right, thank you. Yeah, that's a very important point. Everything I'm talking about here is about systems that still receive kernel updates and want to update their kernels for at least some point in the future. But yes, that is exactly the point when we decide to make life harder for certain systems, like systems with 4 GB of RAM. That would mean we stop giving them the chance to do kernel updates, and then they would be stuck on older kernels.
I'm not getting ahead of something you're going to put on the later slide, but you're talking about just removing completely.
Yes, I'll get to that. Yes, that is actually the like. This is just a recap of what I found out, and then we'll talk about solutions.
Well,
yes.
I know that most of the people here are ARM guys, but actually I'm from RISC-V, and 3 years ago we had submitted our support for Hyman for RB32, and it was turned down by most of the opinions. But we still have customers that have more than 4 GB of memory of RISC-V, and we're maintaining a downstream patch. So it seems like the unpopular opinion here to keep it alive. But anyways, I will comment it later.
Okay, thank you. Yeah, I didn't know that this existed. Thanks. That is important. So looking at the systems that have more than 2 GB, the ones that are usually most vocal are people who have old laptops. We have those across 3 architectures. We have x86, of course. There was like in 2006, you got the generation with Core Duo, like the first Intel MacBooks, the last 32-bit ThinkPads and others. And then we had ARM Chromebooks a couple of years later. And people are still using those with 4 GB of RAM or 3 GB in some cases. The total number of users, obviously, is very small, but these exist. And then on the embedded systems, I have heard back from people running typically IMX6Q or IMX6D systems with 4 GB, which is a very rare configuration because you need 8 memory chips. It makes it very expensive. So they only end up in applications where the cost of the board didn't really matter compared to the overall solution. So for in-flight entertainment, the overall system cost is so much higher per device that you don't care about the cost of the memory. They put just as much in as they could. So you have those, and those are the systems. Those 3 were examples where people told me that they have to have support well into the 2030s.
So you're focusing now on hardware that is 32-bit only. Did you run into any users that were running 32-bit kernels on hardware?
Very few, but those exist, yes. So on PowerPC, like on Core IQ P5 and T1, that is a thing. On ARM, yes, that has also existed, but most of these run 32-bit kernels because they have very little memory. So if you only have 128 megabytes, you run a 32-bit kernel because you save memory, not because you want high mem.
Yeah, we do usually come up every once in a while, but we usually tell them to go away. And
Yep.
We haven't had too many who've been very persistent about it. Usually go away and run just from a kernel, and that goes through.
Yep. So on systems with more than 4 gigabytes, so we have a couple of server systems that people might remember. These are all dead as far as I can tell. There's a couple of NAS boxes with the Amazon Alpine chip, like the first generation Graviton, or the thing that came before that ended up in NAS boxes. They do not get kernel updates, so I don't care. Then we have 2 systems that end up in wireless base stations, so mobile phone network base stations. That's the LSI Axia platform and the TI Keystone 2. We've seen multiple companies who have one or both of these, and they typically run those with more than 4 gigabytes, but they also reserve a lot of that memory for the network stack. And I haven't got the details out of them. What the actual impact would be of removing high mem while still supporting the network driver to access the high memory using this separate mechanism, because that will certainly require development work. They might equally just decide to not upgrade the kernels anymore at some point, but at the moment they do.
I was just gonna ask, like, you're talking about things like mobile base stations and fire alarm systems, like, is it a real use case that we're gonna see those upgrade to like kernel 7.2 someday?
Yes.
Really?
Yes.
Okay, thank you.
No, there's a lot more that don't upgrade their kernel that I did not list on my charts because they don't matter. These are only the ones that upgrade their kernels.
I'm shocked, right? Like, I have done this before, like, I had some of these old armos, and I just tried to go from like 3 dot something to 4 dot something.
Yes, that is the majority. These are the ones that we care about at the moment. Yes. Just looking at the other architectures. Yep.
Just about the networking systems?
Yep.
Usually they just cut out the memory out of the kernel control. So
I know, the question is just how much and how that would keep.
They don't tell how much.
I don't have detailed information, like I don't have the source tree for those. So we need more information. And there's only very few people actually working on those systems, even though some of those might have shipped in the millions. But those are also older systems. So usually the SoCs came out in 2012, 2013 timeframe before they could move to 64-bit. But they have very long production cycles and update cycles. So these are still being used and sometimes still being produced new, even though the designs are old. So for the other architectures, I have not heard anything back from ARC, C-Sky, Microblaze, or Extensor, which are also architectures that enable high mem support and use it in the kernel.
ARC has its weird uses of high mem.
Yep.
They use it like what was this continuous memory back then. They even have high mem as a low mem, so they need it for addressing different lines differently.
Yes.
The part of that is high mem can be linear address at all.
Yes, so I have not heard back from ARC people that still update their kernels. I know what the code looks like, and yes, they clearly need high mem if they want to update their kernels. I just don't know if they do. Spark is an interesting case because their low mem is very limited, but there are patches to make that work with up to 2 gigabytes, which is what people are using in production on embedded Spark systems that still get kernel upgrades. That's the Leon 3, Leon 5 platform for aerospace users. And MIPS is architecturally limited to 0.5 gigabyte of low mem. And fortunately, all the systems that I think we care about are also limited to less than 512 megabytes of physical memory, because they're usually on DDR2. Those would be usually like a Wi-Fi base station setups before the manufacturers move to ARM DDR3 memory. So those are limited to DDR2 sizes, with the exception of one chip from MediaTek that has 512 megabytes. And apparently HiMem is already broken on that platform. Right, let's get to the proposals. So these are the things that I've talked about before. An idea that we've been working on in Linaro was the VM split 4 gig, where we switch between user space and linear map, both using the full 3.7 gigabytes of addressing that we have available. That would solve a lot of the problems. We never fully got it working, and there's currently nobody who's funding that work and nobody who wants to work on it for other reasons. So this is probably not going to happen. And my feeling right now is that we also don't need this. The thing that is more likely to still be needed is the dense mem, which I've talked about in private with multiple people. This would solve the problem of discontiguous memory that still fits within low mem, but is, because it's discontiguous, the half of it is not currently mapped there. This would have some runtime overhead that might solve some problems. We are currently looking for additional help on this. So Linus Valet has started work, but he's currently not working on it. And we'll have to see. Like, if anybody's really interested in this, come talk to me or to Linus. We'll probably need this for the Renesas platforms, like the older RCAR SoCs have this particular problem, and there's a few others. It's very hard to find out which ones exactly, because in the kernel source tree, I can no longer find that information. The one that we'll probably end up doing is reducing the feature set of HiMem as much as we can. So right now, the policy has always been, if something can be HiMem, it should be HiMem. And we can change that policy, so only like the GFP HiMem flag only gets used in a very limited set of places in the kernel. Yes, question. So I've tried to make a list of all the places where we do a GFP HiMem allocation in the kernel.
Maybe you cannot find the memory sizes in the kernel base or in the kernel device base. Did you try checking the U-boot device, the extras? It may contain the memory sizes there.
Yes, but a lot of platforms that are supported in the kernel are not in U-boot. I looked at some of them, but usually I couldn't find enough information. But I can look again. Yes.
Are.
Okay.
Thanks.
Yep. So I think these four are the ones that we will probably keep at least for another 5 years or so. So I was initially hoping to only have the ZRAM, ZSwap allocator use HiMem, which would simplify a lot of the memory management code if we don't have to deal with page cache using HiMem pages. Willie suggested probably using still the page cache, but not most of the other things on the right side that are listed here. And maybe we can look at this list. If anybody sees anything on the right side that they think should still be using HiMem, let me know. And I don't know. So there's a GFP HiMem allocation in user fault FD.
Move it to the right.
Okay.
I think it's really only used for virtualization. And
Okay.
if you're running virtualization, feel free to move it to the right.
Okay, good. Yes. So user fault FD.
I feel kind of the same way about K exactly.
KExec might be still.
Yeah. On the other hand, KExec is already a niche application on 32-bit. And yeah, I don't know how many are using it.
I think the additional cost of keeping new TLB is absolutely minimal, so I would still need it, even though I don't think it's really practically explored. I think it would just create extra drama to remove it, and there's no benefit to it.
Okay.
As opposed to high PTA, was a huge win for high PTA.
Yep, thank you. So huge TLB, that's also what I was thinking, because it's an obvious thing where a lot of memory could be accessed in some form.
Is there a lot of game taking down IAM users? If you're going to have a page cache, you still want driver to go directly into the mount. Or you mean just the underlying allocation of the bounce buffers?
Yes, I think this is for bounce buffers where we allocate memory below the 32-bit address limit, but above the low mem limit.
Because you still want to be able to DNS straight in and out of the page cache. So
Yes, so this is for the allocation. So this list is only where I looked at where we actively allocate new memory, not where we use a K-map to get memory from somebody else.
So I'm not sure where I'm reading this list right. So is a removal benefit say that if we are removing time and solidly, then all these subsystems will break this case, or not reading it?
So the immediate effect would be if you have a driver that uses one of these things, then any allocation that currently uses high mem for these things would use low mem, and you have less low mem available in the system. So
for fields, I think that is pretty. I don't know. I don't think, from my understanding, it is still being very well. I think so.
Yep. So this is more about the general policy, I think. Yeah.
I was just going to sort of say, like you stated, purpose for doing this seems to be that the drivers tend to sort of get a little free and support timing. So some of the things on that list, like vmalloc, I feel like that's a little bit more core subsystem and maybe a little less likely to become broken. But if you wanted to really protect the drivers, I would say you want to do something like say pages can no longer return high-mem pages at all. And that, like some of the IRMU stuff, some of the RDS and Q stuff is all driven by ODirect support. So you say you don't get ODirect to support, or you don't get to register memory on high memory anymore, which I don't know, these platforms doing stuff like that. That would save a lot of the sort of bug surface.
Yep. Yeah, that was the idea. So now we're getting into the really controversial bits, but the first point here is that we make the conscious decision to change the policy, saying rather than anything that can be made to work with high mem should be using high mem, we say the things that are most likely to use a lot of high mem, they get to use high mem. Everything else just doesn't use high mem, so we don't have to worry about it anymore. And I think this one is fairly uncontroversial. Does anybody have other opinions on this? I think the second one is going to be a big this would make news if we decide like anybody who's currently using a 32-bit desktop will have to stop using all of the memory in there at some point when we get to the next step of removing page cache support for high mem. That right. So these are old systems. These are hobbyists using them because they like to use them, not because they are forced. It's not lack of funds for buying a 64-bit machine. At this point, it is people who actively seek out old hardware to play around with.
On the side, many people turn to RISC-V because most of you guys, but then the 32-bit. So I would say many people are switching to restart 32 instead of keeping the older ones. But anyways.
So the other thing is, yes.
I think that the desktop problem is more of it is a vocal minority of folks that
Yes.
like to complain when they hear about it. So maybe we need to fund a computer history museum and we say we have a great place for your hardware to go live.
Yeah, so one thing we could do right now is have HiMem depend on config expert and say, well, if you are upgrading your kernel today and you have 2 gigabytes of RAM, just use VM split 2 gig opt, which then we'd have to actually make work on ARM32. It's currently broken. And if you need HiMem with more than 2 gigabytes, you have to enable config expert and possibly tell us about it. That might be one thing. Yes, question.
I was just thinking about the list that you shared. Like, do you roughly know how much impact from code maintenance-wise it is when you remove some of these features, right? Like, if you remove a HiMem flag from one of these cases, like, how much impact is it actually for code maintenance? I know that some of the IPP stuff that's really nasty, like putting page tables there, like I want that done. But for the other stuff, if it just like specifies like a flag and there is no other code you can really remove besides not having a flag.
So I think in some cases we can remove the K-map. We might just as well decide to leave the K-map. It's probably very little impact. It is more about the impact would be like if somebody's looking at all the possible HiMem allocations, it comes back with only 10 things instead of 200 things.
I think it's what you said at the start, right? It's like,
Yeah.
I think it's what you said, it's the bugs, right? So if you have drivers doing a lot of K-maps, or these K-maps, the chance that your K-maps go missing or whatever is very high. And 6 dot or 7.1, 8.1, it's more likely the driver working. Right? So why are we doing all this work?
Yep.
So I would say to answer the question is it makes sense to target places where there's a lot of HiMap activity and a lot of complexity around the K-maps.
And I want to see this go away because we get bugs about PAE and other HiMem users, and it's like we have to think about it very, very rarely. And those are old brain cells. It's hard to fix these bugs, and we don't have hardware half the time. So it really that's the thing is like if you get one of these bugs in your inbox, you kind of want to look at it, but also like it takes a big time sink. And I would love just to say, you can't even file the bugs anymore. That'd be beautiful.
Mm-hmm. Yep.
I think the problem with K-map for me is that large volumes. Right? You can't K-map an entire folio. You get one bit of it. I've done my best to introduce APIs for that. But
too much throwing it around. So oh, yes.
It's always like.
Yep. Yes, ma'am. Yep.
Yeah, my problem with K-map is large folios. So you can only map one page, up to one page with K-map. I mean, I looked at fixing that so you can map an entire folio, but that's a crazy amount of address space. So you're going to support having 16 levels. So I've started using APIs, but of course the APIs can be misused. I haven't figured out a way to make the APIs not misusable. So,
yeah. So would it make life harder or easier for you if we were to decide that large folios are incompatible with HiMem, so you have to pick one or the other?
That sounds like a different discussion. Are we now saying 32-bit systems don't get large folios?
No, 32-bit HiMem systems, which is a small subset of 32-bit systems. You have to, I think it's reasonable to pick. The question is whether it helps.
I mean, are you saying like a high order allocation is
Say that again?
like a high order, okay, multi-page folio would just turn the, I mean, like, we could just do that. Say that that's how it's compatible, is that you never get memory from actual INET, you're allocating more.
That would probably break the use case of using it for page cache, right?
True, but it makes it more painful, but it's halfway.
Yep.
I ran into this audience recently. I think ARM has like a high order page table level. Is that right? ARM 32. Like the second level or the first level, however it's 16K or something. So if we remove high page table support, are these systems still going to work, or are they going to run out of unfragmented memory?
High PT is only on the lowest level.
Yeah, so high PTE, I think we already put it on the list that we want to remove high PTE anyway. So, no, Russell said that he really wants to keep high PTE, but I think he's the only one who said that. And like if.
But you're asking the $1,000 question, because if that list on the right side gets too long, or there's too much memory in that right side list, which is long,
Yeah.
That's when we run a problem.
What says it's not used for PTs?
Yeah.
So what we could do, like the other thing that I have on my list is having separate kconfig options for each of the remaining HiMem users, so that you can configure each one of them separately, and then also have statistics in procmem info where we say, well, this much anonymous memory is in HiMem, this much ZSwap or whatever is in HiMem, and then we can actually have some data to actually see which ones are used in practice. I'm not sure how much work we want to put in this, if this is actually going to be useful. But I think from the feedback that I got after ELC and what you said, that the page cache, we can probably sustain another 5 years. Let me know if you have other ideas for what would be a good time frame. But I still think that it won't live as long as we support 32-bit ARM. Especially because the systems using a lot of HiMem tend to be the older ones, and the newer ones have less of it. So this problem is slowly getting smaller. So this is the completely made up timeline I put up here, how I think this could end up. So with the VM split, obviously changing the VM split has a huge impact on a lot of users. And the question is how we set the defaults, or how we can nudge people to use one VM split or not use HiMem. We could tie HiMem to VM split 2 gig. So saying that if you enable HiMem, you also get VM split 2 gig. And then they might not actually use HiMem unless they have 4 gigabytes of RAM. That might be one idea. I think reducing the feature set, that's something that I can do. I can produce 100 patches to patch this out of drivers as much as we can, and then see what is left and how we deal with those. And we know some things that will have to stay. The dense mem support, as I said, looking for funding and or volunteers to work on this at the moment. But the 4 gig split, I don't think there will be funding or volunteers for it anymore. I had high hopes in the past, but I don't think this is actually going to happen. And then at some point in the 2030s, possibly early 2030s, I think that would be when we remove the page cache HiMem. Does anybody disagree like anybody have strong disagreements with any of these times?
I would just say try and do it, find a way to do it sooner.
You want to do it sooner?
So like, as an example, we have some guinea pigs that would do some of this earlier. Like, let's say we made 32x86 users like not have an page cache now.
Right.
These guinea pigs.
Yep. So if we have individual options, we could certainly do it differently by architecture.
I even wonder if it's things like we go until you boom because you ran out of low meta. Like take your users that we want to kick out of high meta, right?
Mhm.
Right now, if they have a flag that says I'm going to kick out of high meta, they go to low meta until you boom. Because you're out of low meta, and then we let them fall in. So like the users will be like, and we dump a big splat at that point. Say, hey, this was a problematic one. And then there's comes to work and they can report that to us. We have an idea that they exist.
Yep.
Just a quick question on the timeline. When you were talking about all these devices earlier on, is that, I understand that they're getting software updates and there's going to be new kernels deployed on these things, but is the hardware actually still produced? Or are we talking about there's a finite set of these machines? Because I do wonder about longevity, right? And the ability to replace the components.
Yes, so we have famously the IMX6 with the Cortex A9 was initially introduced in 2011, and it has a support life until 2035, where the manufacturer guarantees these are being produced. And I assume that people are going to build boards until the last minute. We are seeing a lot fewer new designs based on those boards, but they still happen. Most of the new board designs that we see are on Cortex A7 chips. We also get a lot less of those.
It's not just the end of manufacturing date for the CPU, but like the DRAM chips, the power converters, there's a whole host of things you need to kind of keep rebuilding your board. And to me, having worked in that field before, I don't know, 20 years of another 20 years doesn't seem that believable.
So the dates that I've heard from people updating the kernels, certainly in the late 2030s, is not an unusual end of life for existing products. We still have people putting out new products for cost reasons on 32-bit ARM and RISC-V, which are the minority, but some of those will be long-lived. And usually the low-end ones are longer-lived than the high-end ones.
I know, and like I said, I worked in this space before. I've done the purchasing side before.
Yep.
And it's very, very hard. It just takes one part, and you have to rebuild your system.
So the longest times we have seen, and there's a lot more information in my ELC talk, like 30 years for PowerPC chips is something that we have seen in practice, from first chip generation to end of support for the Linux.
So we're almost out of time. How many more slides do you have?
No, this is the end. This one?
The prior ones with the circle graph. Yeah, this
Yes.
One. Yeah, so what is the proposal for the 4 gigs? I mean, the very little, is there any alternative resolutions if we want to support that? I mean, you listed as lots of work, so is there any key major thing you can point us to?
So the best idea I had was to configure ZSwap or ZRAM to use high mem, even if we remove support for page cache. That can still stay an option for a lot longer, probably until the end of 32-bit. Well, the end of 32-bit Linux kernel updates, which is probably around 2040, who knows?
So I have a quick question, which is, if I set a patch set tomorrow to remove high PC, is anyone going to switch?
Russell.
Okay, Russell works for me, I'll fix it.
Yes. No, I think if we as a group here make the decision that we want to remove high PTE, then he wouldn't be able to override it. Like this is, and you can do this in the memory management. Like if the core MM code gets patched to not use it, then it doesn't matter if ARM enables it.
Quick question now. So earlier on, you ruled out the 4 gig split quite quickly, and I think you said it was hard to make it work, and there was also a performance angle to that.
Yes.
I do wonder, since the KPTI work on other architectures, I certainly think the architecture side of the 4 gig split might be more attractive than now. If someone was to do that, is the performance, would that still be that it's not useful?
No, I think it's useful. I think this is mostly about who's going to do it.
Okay.
Like if there's interest in doing this, then by all means we should merge those patches. But somebody has to do the work and somebody has to pay for the work to be done or volunteer.
Could it be done to reduce scope, for example, on 32-bit ARM if that was only done for ARMv7? Would that actually reduce?
So the scope is already limited. Like the only architecture I can see this actually working on in practice is ARMv7-VE, so Cortex-A7 and Cortex-A15. In practice, only Cortex-A15 and Cortex-A17 are the only ones where this would actually make sense. So Cortex-A7, you don't have 4 gigabytes on any system I know. Cortex-A15 and A17 are the ones where people have 4 gigabyte or more.
So I think we are at time. I want to make sure the next speaker has enough time. But thank you very much. Let's thank the speakers. There we go. Alrighty. Yeah. All right. This was definitely one that had a lot of discussion, and folks that are wanting to have more discussion, feel free to have it out in the hallway. So we can get started with our last presentation before lunch. And so let's give a warm welcome to Dave Harley, who is going to be talking about DRM and C group management.
Thanks. Yeah, for people that don't know me, I'm Dave Early. I'm a distinguished engineer at Red Hat, the upstream GPU DRM maintainer. And this is something that happened this year that I was forced to deal with. Not by choice. It's very rare I have to do something, but this was a had to do. People ask questions. But before I get into what I had to do, is I just wanted to give a bit of a sort of a history of why it hadn't happened before now. GPUs, sort of memory history. Like traditionally, GPUs have only been in client devices. Nobody really, cared about them beyond this single user space. We had, typical either unified memory GPUs where there was system RAM. There was a lot of laptops, a lot of desktops, a lot of embedded devices are built around that. We have discrete memory GPUs, where, laptops and desktops with a PCI Express card. VRAM being just device memory. So a lot of our, sort of standard use cases for GPUs and DRM was mostly just devices that had a single user. No one really cared about actually. I'm sure people cared, but no one cared enough, put it that way. But some of the other these are little small asides. Like, one of the sort of differences that GPU memory allocation has from standard thing, I'll go into a bit more, is that we do like to use on-cached memory in a lot of places for just these small extra speed-ups. And GPU virtual memory is a thing, but we don't have things like page faults and stuff. So there's quite often no real advantage to doing page-based allocations. We have to sort of do things at a bigger level because we don't want to be swapping in and out of the page level granularity. Even now, we don't really have useful page faults. So It's just the architecture of how they work versus CPUs is often different. But so what happened? Well, HPC kind of happened, but really, was the start of it. Again, people cared, but did anyone want to pay for it? No. But AI happened, and suddenly the combination of these things, people suddenly started caring. What changed in the architecture? So suddenly people wanted to put GPUs in servers more and actually use them. Quite common configuration that we started seeing was like putting 8 discrete GPUs into one machine, like using PCI Express, using like NVLink, AMD's Infinity Fabric. There's been a number of different architectures of things, but it seems to have sort of, the industry has settled around like 4 and 8 GPU boxes is kind of a thing that seems to be useful. A lot of those were a single CPU and then discrete GPUs, but there's also been a push for more, like, I'm calling them APUs because that's what the old name for them was, but it's combined CPU and GPU on a single chip. These often have coherent memory architectures. Mostly PCI Express is non-coherent. You can have snooping and things, but these are actually CPU GPU coherent memory architectures. The CPU could be an x86. It could be an ARM. I don't think I've seen a RISC-V yet, but I'm sure it'll be out there. One of the ones that everyone where this problem actually came up to me was on the AMD MI300A architecture, which is their first one of their like MI ones that is an APU, that the CPU and GPU had shared memory architecture. There was no discrete video RAM, no device memory. But other ones that are on the field that you may have seen is the NVIDIA Grace Hopper, Grace Blackwell systems. They're also using this style of thing. So this happened in the last few years, and suddenly C groups started to matter to people. It was like, okay, yeah, because we want to be able to run multiple things on these. We want to be able to have multiple users. We want to be able to schedule things. We want to be able to, have limits on our server memory usage and things like that. So suddenly people started talking about C groups. But also worse than suddenly C groups mattering was suddenly NUMA started mattering because people wanted to be allocating their pages on the right node nearest the GPU. And in these unified architectures, you had multiple MI300As in the same fabric. You would have to allocate on the right one. So that's where I got involved. It was like what C group matters and NUMA matters. So I'll just give a little overview then how the DRM sort of memory manages before I get into when I joined the two. The basic sort of unit of GPU memory is called an object. It's usually a bunch of pages. We don't, as I said, we don't use single page sort of tracking. We generally track things at an object level. This primarily comes from more the graphics side, but compute still uses this model in a lot of places. It just means you have a single object that if you need to move it around, you move the whole thing. You don't ever need to address pages. You can't page in and out. So the whole thing has to be present and valid for it to be useful. So there's no point messing around with like just doing some of the pages. We have the sort of gem object encapsulation that's used by nearly every driver to encapsulate their objects, but we also have a sort of next layer internal system called TTM, and we use that when we have a case where there's device memory and system memory. We want to still have an object, but then the object could move between device memory and system memory. And TTM is there to provide that support to let you migrate objects between the two. So it's still a gem object, but inside the gem object, you've got a TTM object, and the TTM object then controls what's inside that. TTM also provides, as I said, the on-cache paging stuff, all the support for dealing with on-cache pages and keeping track of them and pooling them is all done by TTM. TTM has a shrinker for buffer objects. We call them buffer objects as well as the sort of internal name. This is called from the driver. It's called under memory pressure for reclaim. It will, first of all, it will look for any objects marked as discardable. That's not a very common thing. There's not very many reasons that you would allocate a GPU object as discardable. But people have started adding this, so there's like one or two small use cases that it's happening in. But otherwise, it will start pushing out the swap. It will start pulling your pages, allocating SMEM, dumping it into the SMEM, and then letting SMEM swap it out. So that's kind of how we do things at the moment. One of the little this is one of these problems. It's like it's not a hugely common thing, but it's a really annoying thing, and you sort of have to support it properly, but it's also, we could do without it, but there's enough use cases that it's worth the pain. One of the things you get on with, cache memory, you can, over PCI Express, you can snoop it. It's like, so the GPU can see when the cache memory changes, but that has overheads. And if you don't have to have those overheads, well, you probably can avoid them, and especially with GPUs, people really, really care about like as fast as possible in every corner. Also on a lot of the APUs, even where there wasn't a PCI Express bus between them, having an on-cache mapping would like give you a small incremental improvement over not having it. Of course, everyone cared about this. Why is on-cache memory complicated? At least on x86, one of the problems with PAT, the PAT table page attribute tables, is that you cannot have pages with multiple mappings in the same in the system at the same time for the same page. So you're not allowed. There's a lot of rules about what you are not allowed to do. Yeah. So it's like you have to. ARM64 is to say. So it's like we have these APIs that we invented years ago called set memory UC and WC, and they pretty much their main job is just to remove stuff from the linear mapping so that you can have on-cache mappings of those pages and put them in user space and map them in wherever you had. But the transition between cached and uncached and back and forth has overheads. So we have to mitigate those overheads, because if we hit them on every single time we allocated a buffer object that needed them, they start to add up. So we use a set of pools. We have to call them, they're caches, but because we're talking about cached and uncached pages, of course, we have to give them a different name. So we have a set of pools in TTM that keep track of when we have a bunch of uncached pages, and we keep them around so that the overheads are mitigated. We used to actually pool cached pages, but about 2 or 3 years ago, I think we ripped out the cached page pool idea because it didn't really make sense, because we were just taking memory away from the system that the system allocator should just be as good at allocating. So we got rid of that. The pools also are NUMA specific. Again, that was something that was added a few years ago to handle the fact that you needed to keep these on-cached page pools tied to the NUMA node. And I think NUMA was also one of the reasons we ripped out pooling the cached pages, because, again, you needed to have all the NUMA infrastructure was much better at doing this than we could be. As I said, pools only get filled on object free. So the first time you create an object in the system with uncached, they will do all the work. But when you free that, it will drop all those pages in the pool, and it'll continually do that. As things are freed, and new allocations will come out of the pool. Again, there is a shrinker as well. So there's a second shrinker in the system, in the TTM layer. And that, when you hit reclaim, the first thing it does is go in and gets all of the uncached pages that are sitting in the pool and sets them back to cache and gives them back to the system allocator. That's like a very low overhead shrinker. If it's like very quick to run, but again, you have to go into reclaim to do that. So, and that's a bit of a painful place to be. You don't want to enter into reclaim just to do this. So what can C groups do to start helping some of this problem? So about a year, maybe 2 years ago, we've had a lot of C groups discussions over the years about how we could use things, but someone finally gave in and wrote at least a device memory controller, which was enough for us to at least track device memory allocations and say, okay, you have a budget, you need to stick with your device memory allocation budget. This is the DMEM controller. I won't go into too much on this today. It exists, but we haven't really used it in a lot of scenarios yet. But there will be a bit more work to go in the future. I'll get to it. But the big problem, of course, I had was how do I track system memory allocations. The MI300A device that I was faced with has no device memory. It just doesn't have it. So it's like, I need to start using system memory allocations. But of course, I should just use MEMCG. That's what the memory secret controller is for. And that sounds nice and simple until you have to sit down and do it. So started little problems that I faced as we went along. So even if we do say, like, I'll use that MEMCG in that unified memory architecture, but what does it mean in the non-unified? Even when we have device memory and system memory, and I allocate an object that could live in both, how do I account that? Do I account it to the DMEM controller? Do I count it to the MCG controller, or do I count it to both? It's only ever in one place at a time, but you have to be able to deal with the fact that it's going to move. And so mostly you want these objects to live in device memory, and you will want them to count to the device memory. But occasionally someone will overcommit device memory, or someone will cause you to use more device memory, and you will have to kick something out. That's where you hit the problem. Like, this is one of the sort of fundamental problems that nobody has solved, and I think it's why nobody has moved forward with it, because they think they had to solve this to move forward, but I think we can deal with it. But it's like, when the eviction happens, what do you do if there's nowhere to put it? Like, if process A has used an object, his object in device memory, and then process B comes on and kicks it out, who has to account for that system memory allocation that's going to be used when it gets kicked out? Is it going to be process A should have accounted for it, but what happens if hasn't got enough overhead in its C group? Like, what happens if the MCG that process A is using has no space left in it? Well, where the hell is this memory going to go? Do I still evict it? Do I fail the eviction? But then process B is getting hit with problems because process A has done something bad, and then that sort of breaks your container and your C group idea, like that these things should be completely separate things. And this is one of the ongoing problems that we have to solve. But it's been a big one. There's been a lot of discussions about it, and it's going. I don't think there's an answer for this, other than you're going to have to just realize it's a problem, and hopefully you can configure your C groups to not let this happen. But it's a messy thing to deal with, because what do you do when another process is doing something and you have to account for in the original process? There's no nice place to suddenly return enomem. There's no nice place to suddenly tell the original process A that you've run out of memory, because it's not even executing at the moment. And probably the next time it executes, the first thing it's going to do is push all those objects back into VRAM, and then it won't have run out of memory anymore. So there's a lot of how do we solve? This is a very there is no solution to this yet, but it's something I want to make sure we have on the records, and people will know that what slows this down. Another problem is, question, Mike.
So what's the lifetime of those objects which has to be migrated within these two? Are they associated with some process of that A in the previous slide? So another might be like killing stuff as well. If there is no one, I'm wondering if the lifetime you can associate with some process.
Oh, generally objects have a lifetime associated with a process. Sometimes there will be DMA buff shared between multiple processes, and again, there's also issues with what you would sort of call priority inversion, where a lower priority process could share something with a higher and that we see that more on desktops as well, where you've got a compositor process and somebody submitting something to the compositor process, and if this process can actually cause the compositor to run out of memory, or get the eomem into that, you've pretty much DOS'd your desktop by using C groups. So it's yes, they are usually attached to a process, and in those cases, blowing away the process isn't a bad thing. But if it's the compositor process, that would be a bad thing. So it's how to make a policy around that. It's very hard to know. So the on-cached cache pool overhead was another problem that came up in the C groups discussion, and this was actually a bit of a C group people versus DRM people mismatch in terms of what was the responsibility. The DRM, one of the other DRM maintainers, was he sees our whole cached to uncached setup as a workaround for the fact that the core kernel doesn't do this. It's not his feeling is that it should be an MM. MM should deal with uncached pages, and the reason that's not an MM because the only people who ever needed this were GPUs. So nobody, it was always, well, just do it in your subsystem. So that sort of contention has sort of never really gone away. And the C groups people are like, well, it's a DRM code, so it's a DRM problem. And he's like, so there's been a bit of a lock there where they just get a bit annoyed at each other. So some of the scenarios that were happening was as I said, C group A allocates a bunch of uncached memory and it feeds it into the shared pool. And then C group B allocates some cached memory, and then the system was under memory pressure. So at that point, B has to enter reclaim to get the on-cache pages out of A's pool. And that's not, again, it sort of violates the container, ruling of like you shouldn't cause other containers to do work that they don't need to do. But because of this fundamental, well, that's actually the MM's job, and the MM should do it, and we're just doing it as a workaround. We fell into a lot of discussions. I've kind of resolved that one, at least to the point of like, I'm sort of come down with the C groups people on that. It's like if one process allocates like a gig of on-cache memory and then immediately frees it and then allocates a gig of cached memory, it should just pay that overhead on that, that pool and do it itself. There should be no need for like to cause another process harm or cause another process to have to go into reclaim. So I think that one we've kind of solved. The DRM maintainer on that side is not as, he has some, there are some, like when I started this, there was use cases I was like, this can't be real. And he would like then sit down and explain to me the insane use cases that he has in the real world executing on things. And I'm like, okay, yeah, I get that, but it's horrible. And one of those, is they would do things in certain systems where they would just start a process at boot and it would allocate like a gig or 2 gigs of on-cache memory, and then just the process would die and it would just drop all that memory back into the pool. And then every application that started up after that would be able to use stuff out of the pool, and they would even out their overheads. It was, I'm like, yeah, that's the thing. I could see that happening, and I've kind of dealt with that in this framework. That when C group now drops pages, they go into the parent C group, and the parent C group, then it can allocate from the parent C group if it needs it. So the hierarchy is there. He still wasn't entirely happy with that because I think he still had another crazy use case where he doesn't do that, but he had multiple processes all doing like what would essentially, one of the main uses for the on-cache pages is scan out buffers. And he had multiple like games, I think they were in the scenario running, and they were all using the scan out, wanting to use the scan out, but only ever a few of them were using it at once. So it was like, there was no need for everyone to have their own pool of fully on-cache pages for the size of your scan out. There only need to be one set of these in the system. And with C groups, that's kind of hard to do. It's like, yeah, you have to own the memory. So this is sort of one of those, I don't know how to solve that in that use case. I think we just have to deal with the fact of using C groups in that use case. You have that's the whole point of having containers, is that they are separated, and having this like, little thing is nice optimization, but just turn off the C group integration if that's what you want. But then, so that was like the problems and where we've come from, but how do I actually move forward? How do I actually make any progress on this with this thing? So the first sort of thing we agreed on, well, let's start by at least accounting. So one of my first set of patches was to send out, just adding some MCG counters for both GPU active memory and GPU reclaimable memory. The reclaimable memory was any memory that was in the pool. So anything that once we entered reclaim, we could easily give back. And then active memory is whatever was in use. Some of the first feedback from the C groups maintainers was, well, we don't really be wanting memory counters in MCG that aren't also VM counters that we can't see in proc VM stat. So I was like, okay, let's just do that first. So I went back and started again and was like, well, let's add VM counters to VM for GPU active and GPU reclaim. I started using those for the TTM objects. And then we started adding the MCG counters on top of that and started using them. It seemed like this is a simple plan, but not so fast. I had to step back and realize, well, MCG is very NUMA aware, and the TTM pools are as NUMA aware, but they're also very not the same code, and their NUMA awareness, like, although it's parallel, like there's no real, they don't understand each other's NUMA awareness, and there's, have to resolve that. So that's where the two tastes came in. I had to sort of merge the fun. So I had to start by looking at, well, how does MCG do this? List LRU is its main mechanism for keeping track of the pages in use. So I had to, first of all, move all the TTM code that we had our own LRU in, and our own NUMA management in, and our own like layers of stuff like that for the pools. I had to port that to list LRU. That was actually surprisingly nice. I was quite happy with that work. That makes, then we had to make the shrinker. So the pool has that shrinker. that has to become NUMA aware. That's not actually too hard. Once you start using list LRU, then it already has pretty good shrinker integration. So that wasn't too bad. We had another we have our own max allocation thing that was per like system. And I'm like, that doesn't make a lot of sense. And I moved it down to per NUMA. There's a bit of contention around that, but I think I'm going to get that passed. So then, yeah, once all those little things, we use the LRU and NUMA. So we turn on list LRU first, and then we turn on the NUMA support in the shrinker for TTM pools. And this is where I wrote that piece of code that said, when allocating an on-cache page, if your C group doesn't have any, we'll check the parent C group. And then when you exit, all of your on-cache pages you had at exit will go up to the parent. And that should maintain some of the hierarchy we need to see in like desktop scenarios and some of these other scenarios. It's not the ideal one for the crazy corner cases, but that's like just turn off C groups if you want to do crazy things. It's driver opt-in at the moment. The drivers decide which gem objects should be tracked by an MCG. Pretty much all objects controlled by user space should get tracked. There's not a lot of internal object allocations in system memory anyway, but they probably should be tracked. We'll get to that. But right now it's just dealing with it from the user space objects, because they're the primary place I can return enum and tell the user space that it failed its allocation and it's run out of space. So yeah, TTM's page population gets a little MCG flag, but the problem here is that we populate the TTM object pages in two places. One is on the first allocation of a system memory object. So an object that is only going to live in system memory and not device memory. The first time we allocate that, we will allocate all the pages for that. That makes a good place to do the accounting. We can say that it's easy to say enum at that point. But I've avoided doing it on eviction because I do not understand what the semantics for eviction will be. But I think for a lot of our use cases, it's good enough just to get this, especially for the system where the MI300As I was dealing with. They had, I said unified memory, but they also had no swap. So a lot of there was no way to kick anything out. So it was like, even evicting out of the system memory, the swap wasn't going to happen. So they were sort of constrained in that. But for device memory, I think it's just, you just have to leave some sort of, we either have to figure out how to leave some slack in your system, your MCG allocation space, or figure out how to get the enum up to the correct place or crash the correct process, or, the OOM killer kill the right thing. There's a little bit of work there. So yeah, currently I'm only going to populate on that first allocation for system memory objects, which saves the problem in the MI300 system at least. Well, where's this going to go next? I think I've posted the patch set about 8 times now, 7 or 8 times. It's always fun when you maintain a large subsystem and don't want to merge your own code. So I have to actually wait for a review from people in my group, and I don't really like putting pressure on them that much. So I've been a bit slack on it. I think I've posted it 7 or 8 times. I'm hoping by talking here today, I can finally push it and start it next year. I wanted to see. I'd like to get it out there at least and see what breaks. We've done a workaround for the customer that had this problem by using DMA buffs and a few other sort of hacks up in user space. But I'd really like to get this done. And UDMA buff was what I think we ended up using to do it, and it had enough accounting to get us through. But I'd like to do this properly. I actually see this being useful in some laptop scenarios that I hadn't really considered before. We don't always make the healthiest decisions in the OOM killer when we have laptop, like Firefox doesn't always get the right thing blown away. And then I realized, well, yeah, actually on your standard Intel laptop, there's no tracking of the memory that's GPU memory allocations. If you're doing a GPU memory allocation through like Vulkan or OpenGL or DMF, it's not accounted for to the right process. So even doing that should hopefully fix some sort of weird problems I would think on constrained laptops that they would crash in maybe a healthier fashion. Not sure, but I would like to get the code out there to see if that has any impact on that sort of scenario. yeah, like how do we handle these evictions? Should we handle them? Is there a good idea? If anyone thinks of a good idea, definitely feel free to talk to me about it. Someone has suggested a few times, one of the other maintainers, that we should just not care about this uncached stuff, that the additional speed up achieved by using it is not actually worth it. But when we shop that around to some of the Intel maintainers of their GPU drivers, and they're like, actually, I think we actually have some actual problems not doing it. Like there's it's not just like again, AMD are like, yeah, we think it's just a needs an optimization, and Intel are like, yeah, no, I think some of our GPUs actually need this to function properly now. So it's like we still have to go with it. But the question of like most of the work in this has been for that one corner case. It's like, is it really helpful? Is that probably not actually going to have a huge impact on the systems? But we probably have getting it right is probably important. Yeah, like will the new code, like lots of flying leading onto cache pages regularly? It's probably not a likely scenario we see, but I want to see. Yeah, that's probably zoomed through that, but lunch is coming. So if anyone has any questions, please.
The NCG charges for the system memory require.
Yeah, I'm not hearing it, but is it? Oh no, it's just low vol. Oh yeah, get right. Yeah.
Right. So NCG charges for system memory requires the memory scotch front page associated with it. Have you not seen a problem with RL or something? It seems like you must have always had memory that has front page associated with it.
Trying to think, we got all of the memory that we're using for at least the cache to non-cache pooling, and this is all done with struct page. I have not dealt with like any of the CMA carve out area. And one thing that I in the code that I've currently submitted, so we have the pool infrastructure that we have actually covers not just cached and uncached, it also covers DMA allocations and 32-bit DMA allocations. So we actually have more pools. And I've kind of just gone, yeah, we'll deal with that when somebody else gives me a machine with that and tells me this is a problem they want to solve. But right now I'm like ignoring it. But yeah, there is a bunch of that DMA pool and stuff. And I've gone through a lot of iterations of integrating this with MemCG. I think I've gone through 6 different implementations of how to get MemCG and this to work together. But I think in the end it was always, because the GFP account flags and there's a bunch of things like that you could use, but I didn't want to use in the end. So I think in the end I've added another set of APIs that use struct page, and set the bits on the struct page, the MemCG bits. Anyone else?
Any other questions?
Yeah, early lunch.
All right, let's
Jet lag? I'm busy now.
Okay. You never relocate, so you actually write to the function.
Oh, or you use it.
Yeah. For APU use case, slope, right? Directly.
No, that's only something. It's actually a faster memory
Yeah, from the memory that doesn't.
Oh, yeah. So the currency also has.
Oh, yeah. Yeah, you don't. There's a lot of
And it has to be done for the performance, so that CPU still in the all of them have the start pages and it's still appropriate for purpose. And when you do the change, do you think it's removed from the direct method?
Yeah.
And the tools are mainly used like the course of this. Basically, equation which is like making some of the uncached to the cached.
And the second scenario is usually when you've
So from the deep you have someone like a mentioned associated with the process. So that process is in the deep controller. It would be in some entity controller. So you can like go back and find which message should be charged.
Yes.
And basically like here if you
I had around a lot more.
so you can use something like this force charge. The next time that process like it will does the education.
Yeah.
It will do the reclaim. It will do. So I think that's
Yeah, so so when I first wrote it, I wrote this, basically a
But more likely what's gonna happen is you're gonna get your it's gonna show you up the street. Because that's when it's easy.
But the fact is, you're right. It's simply just copying and portions of
The practice you got for the process trying to balance it out, you can move it forward, that probably will happen.
And I haven't done it right now, so it's hard to try to go in.
It will be like people will see
It's not even performance improvement. It doesn't
It's performance.
but it's a little bit.
Oh, that's the then you do exactly. It's unlike the normal computer workload where you automate and you running high.
So you're
You didn't set your jobs with the slow jobs, so slow jobs will actual.
I need to do this anyway, because I need to get to a state where, because I'm not doing.
I knew you better than that, right?
How do you currently figure out how does currently delegation? Specifically, I wrote that years ago. I know what I did. It's completely horrendous. It's
You don't know what company.
so there's still a lot.
Yeah, okay, that's what I did.
Because,
No, it is safe, like I did that. It's the vendor that figures out what device nodes it needs to pass in, because my biggest price has always been, because we can also have the same logic for filament cards, and filament cards have an whole device, right? Like for example, the SRIOB device, you can split it into network devices disappears from the files get removed as well. But in filament devices have much of nodes, device numbers, verbs, and whatever shit. So also need to pass those into the container. And you basically parse out to figure out what the combinations
I don't know, because when I took off, I had like a different day. I lost their day to day. I think it's yesterday. So I don't know. A couple days ago. Start of the week. A little bit. Yeah. So I'm coming back here. Yeah. Well, we're not doing that much. We're doing, I think, 2 weeks, but we're going here, Kyoto. Yeah, that's the one thing we did.
So I have
There's
a video still have the
like
virtual students the GPU. I guess we don't let's don't I was very approach. It's already supposed to very dry back. Exactly. That's the one. Years and years ago.
It looks out that way with the
Yeah.
The reason no March 1st I'm exploring.
We still have this problem though.
Yeah, schools.
It really doesn't matter, but when you want to do proper device management, one of the issues is that maybe not too big of an issue at all. But if you pump in a device in host, like you get a U event right analysis itself, like and then system runs, adds it into its database.
Yeah, that's a pretty that's another way of saying it. I don't think Canada's like U events. It's like except for Quebec. And then Quebec is like off by like a week.
I made it so that you can reject U events. Essentially, you on the host, could listen to the events arriving on the host, and then when you're lost that device
the tickets are very expensive.
It's supposed to be moved into the container. We just inject the events into the container. That's one solution. It's completely ugly because like you need to parse it. Just basically to strip up the sequence number. And then the kernel adds the sequence number to that and forwards it into that. It's completely ugly. The thing is, like all of this device management stuff is completely broken, like, because we don't have anything that would work with containers. And I have patches with the namespace DevTempFS. So we did it at least for block devices. I'm really wondering whether I want to do this and like a namespace it properly.
Yeah, I mean, we've had a number of
giant can of worms because it means namespace and that's as the reg is fine.
People often just assume, the code just assumes that things are fine.
It has
we don't really
interesting implications because, like, how do you want to namespace? If your namespace is now, you can use the network model, like where the device disappears from the host and then pops up in the container, so it only belongs to a namespace. But that's potentially shit because, like, system probably or your host and service manager wants to know all of the devices everywhere, so it wants a full list of system. So the system is on host, it would have to be special. So it's really all sorts of issues.
And
Yeah.
so either
Because there's some
try to
attention
do
to
it
it.
correctly, then it would be a giant app set.
It's something between you think
I'm confident I could do this work.
Yeah.
scale up.
But the other option is that we deviate. Right now, the way it works in the containers is that you will want to provide the same API experience that you have on the host. So you just pass through the device nodes and everything just magically works.
Some of
I
the source
responded to Leonard about
NVIDIA,
whether we basically just abandon this approach.
everybody else.
In a sense, like you could still do it, but via systemd, for example, on a systemd service or
Comes from the.
container that you provide.
Actually, I could, yes, but
API
there's a lot of
messaging.
inside.
Oh, really?
Also
So that where you get all the U events, like systemd, when it moves the device into a container, it has systemd it. This stuff, right? So it could move it into the container, it could give you all the U events that belong to it, stuff it into this filing socket, and then give you the files for the devices that get delegated to you. It doesn't necessarily move the device nodes and all of the events, and then probably some more belts and whistles, which might be, so this outsources the whole problem to user space. But this
already deal with OpenAI.
that programs are just
And they need to give them,
and that traditionally has been itself.
Yeah. Yes.
I'm not trying to make that.
No, you've got two,
yes,
there's two kind of comments that you were doing.
but they have it, so it's like a file.
Just standard virtual functions.
Great.
And that has also been the default native context where you just pass through the
Reality.
constructor into the VM or
The-
and
Yeah,
and
it's
clock
it's
the
memory.
passes by a package VM into a host and
multi-die.
Right, so these are the cores and these are the.
Yeah, everybody said that.
Where are the control?
It's just running like
In-
you have the, info user space inside.
And
Now scales on the die, or it's a
Yeah.
lot of, it's on the die, because this is it for 500. Now we put up 180 and so it will be even more.
Yeah, but not bigger.
That's because some people how much.
Yeah. That makes sense.
Because we had all the abstraction for very creative.
Well, the power doesn't make
Build
sense.
on top of
when you
that,
start
now
adding
that-
up how much people are
Right, I have a
saying.
GPU that exposes the same because that's where the whole started.
Yeah.
Power of the grid.
They have a cooling issue. Okay, it's cooling.
So anyway, it's just something that I wanted to bring up. If you have any idea, maybe a discussion. I'd like to know about this because like, this is an interesting problem for us as well.
So that pool stuff, that must have some sort of overlap in networking because we have.
They'll get it done. I think originally who did have a lot of, probably like
Yeah.
Bunch of where one block on the GPU. Video.
Oh, and so you'd have to shuffle things through.
And some of them, great, video. I got maybe 47-bit images, except for this two things. What's up, 40 bits?
That's nice.
Big enough.
They probably just took the IT block and dropped it
Yeah,
out.
that's the standard. They flushed the spectrum, their driver has those. Another picture, is it becomes 40 bits? Yeah, try again. Another 40 bits. Yeah.
Oh, really?
And then it's just like,
One,
switch
two,
to 30.
testing.
Yes.
Grab the boxes.
Yeah.
Testing, 1, 2, 1, 2, test. 1, 2, 1, 2, test, test, test. 1, 2, 1, 2.
What do you usually drink? They also have like I was able to leave, I was able to drop the bag off, and then my legs stopping there. Like after, my flight was 12 hours. Before that, I had to take a train for 3 hours, and I was like 2 hours early at the airport. So I was like for a long time, I just wanted to take a like hot shower and the next 30 minutes to walk around. But that's why I saw some stuff. This now it's staying 4 days. Will give me your first time to check out? Second time? I've had a few patients in Sri Lanka, probably China, Korea, and another it's going to be how many hours is it? Yeah. It's roughly the same as travel to. I mean, like, minus side and plus side. And that's because you can't listen to yeah. That's a problem because we have right now we have tea where there are people from US, from Europe, from India, then from Australia. It's impossible to find a slot, so what we do is we have like a meeting bi-weekly, where we move it every week, and then we have a weekly meeting, but every 2 weeks, we move the slots on it. It's like some people from Australia is just like. I don't want to feel disconnected. How come you were able to get the Was it from Korea? So it's like each semester is essentially like one semester is mainframe stuff. Instead of strikes, video encoding and stuff like that. But that's stuff on KM and so the system. It's when I was when I graduated, they didn't have a job for me, so I was going to do something for a company. I did that for 1.5 years. I had a job for me, so I started working for IBM. After a while, I wanted to go to university again with my master's. For 9 years, I think kind of there are also projects like a 6 inches to 10. I don't know how it's still
You have to like it. At the same time, I think a lot of people just kind of do it. It's a different level of complexity, but it's not the sound you do. So then you have to do this people as well. And so it's upstream work itself, another one, they want to run. You have to learn how to play these games. Similar to this, what's it called, KHO? I mean, similar, like we get similar stuff. So a few years ago, already, different takes and stuff, and it's also like a proper framework, it was more like X. It's not like, like 3 different calls. Now, like 12 years later, it's all you can Yeah, absolutely. I'm sure we'll talk again.
Someone wants people happy. Well, also, it seems like everything. Well, it seems like It's like you can see this That is finally finished now. But now my own neighbors, like, next door neighbor, is completely, like, started just, it sounded like, okay, just shut them out. But then suddenly I saw like walls and things taken away, and like some other neighbors are getting really getting panicky because he takes away walls which are needed to hold the building up. So they will destroy the whole place of this work. And once it starts to chilly. Because no one's has will protect the will. Yeah. Without for them reading the rather than you might have some, but actually, every agency has a principal system separate. So
Of course they have.
I want to bring one about what's already is kind of very simple. So what you look at various it's various grades of energy, how much pollution. Yeah. Yes, I think sort of I think it's also very special because first as and family I mentioned, but it wasn't and then it was some pieces of oranges. And I had like was also just the bit of patience reminds me of something. Sometimes not. I have to fly I'm there, directly go stay 2 nights there, and then it's already enjoyed they will see people but for me it's interesting
Trump depends on das habe ich nicht nachvollziehen. Wenn ich sage, int x gleich 0, wenn du sagst, das ist not initialized, das kann nicht sein.
Not so big. No AI, no AI. It's about file system, no AI. Okay, it's time. Welcome to my session. My name is Cole Lee. I used to work for SUSE, and now I joined a startup named Finyu NAS. This talk is about the file system access control in the AI era. That's the new challenge we encountered. For this talk, I don't provide any solution. I just share the information, the new thing, just show up in the past. I think the past 10 months. Yeah. That's what I want to share. The Evernote is a AI native NAS operating system. That is what my team is working on. This is for home and small business usage. The key feature is we don't force user to buy expensive hardware box. And the user can choose any hardware they want. Now it's x86 64, and ARM will be following next year. So people can choose the hardware they want, the cheap or expensive, powerful or weak, all fine. And they install our software and provide the consumers level NAS operating system. And more than storage, this is not a legacy storage devices. We provide AI stuffs to have the users can analyze, process their data, to monitor data, find the deeper, further interconnections among the data. For in my talk, I just gave the photos as example. And currently, typical user are family members and close friends. So just imagine the photos. The users use the application mobile phone or something else, upload their photos to their private directory. And then the AI agent on the device just try to analyze, to process their photos, to find the interconnection between each photo, or try to put the photos into categories. And then when they find something useful, and the AI just recommend back the new categories, the relationships of the photos back to the users. And when, for example, maybe some category just recall the sweet memory of the user years before and make me happy, then we provide the positive emotion value. That's currently why people want to use it. But you can see that for the AI to analyze the photos in the private directories, the AI agent they can read the pictures and they can write the pictures, but they cannot delete the pictures. Write means not at this moment not change the photo itself, just change the metadata of the photo. For example, some parameters of the JPEG or PNG photos in the header, something like this. And if the user finds some category, that's group of photos, they're interested and want to share to other users inside the system, then they just share the photos, and another AI agent or AI agents just create hard links to the original photos to some public shared directory, and there some other AI agents will continue to process the photos, but not from the individual user, just among all the people, all the photos shared by all the users. Then they can find more connection among the photos from different peoples altogether, and maybe find some new categories, and then recommend back to users and recall some more sweet memories between the family members, for example, the son and the father, maybe they just hack together, but go hacking together, but take photos each other. But this AI can find, they enjoy same event. But the father or the son can see the picture from different view and then recall, that's sweet, something like this. This is the current use case. So for the public shared photos, the AI agent can also write the photos, but they cannot delete the photos. Permit the AI agents to delete the photos. That will be disaster, because most of the AI agents in our system are not developed by ourselves. They are from the third-party developers. So we just gathered the AI agents on something we call agent store, something like this. And the user just select something and install and process. If they like it, continue to use it. If you don't like it, just delete it. So for the privacy protection issue, if someone found the shared photos, his face show up or something else show up, and he or she doesn't want to, then he can ask the agent to delete all the photos had his face or something, because he's the face owner. And so the agent will try to recognize his face to all the public shared photos and then delete that. For this agent is developed by ourselves. Yeah. We need to trust it because this agent has the delete permission. Yeah. And so there are three types of agents in the system. One is the agent work on the private photos. This kind of agents are installed by the user, the individual user on the system. Another is the agents on the public photos. On the public photos, the agents are installed by the system, but still on the agent store. So another one is the privacy agent. For the privacy agent, just developed by our own, because the agent can delete the photos, but indeed not delete the photos, just delete the hard link. When the users share the photos to the public shared directories, we just create hard links to the original photos. We don't use a ref link or just simply copy to reduce the space cost. So the AI agent store will be provided for many agents, and on the private photos and the public photos, there might be more agents developed by different developers to scan on the photos, because different agents have their different specific capability. So that's quite common that the different agents just scan the same group of photos, result different suggested category, and then all the agents scan all the original photos and the new generated categories again and again and again. Just continue to try to find some further interconnections from the photos. So the critical security principle is the third-party agents, they won't delete or corrupt the private or public photos. Yeah, we permit them to write, but not delete. So based on the above explanation, we found there are 4 requirements that they're not fit by current access control method in Linux. The first is explicit deny. Just like I want to share for example, the father wants to share some group of photos to other family members, except for the children, for my son, something like this. Currently, we can only allow someone to access the photo, but we cannot explicitly deny the user to access that. And also, maybe the father want to deny all the access to the photos, except for the wife or for the parents. It's possible for current PostgreSQL, but just we want to unify the operation. This is the requirement, explicit deny. The second one is writable while non-deletable. I guess maybe from the FS code inside the kernel, there's no method to implement it yet. That is the agent on the private photos, they can create hard links. The hard links, the category, I named the category, that's once the AI agent finds some relationships and can be recommended to users, then he creates a subdirection and create hard links and point to the original photos. Then when the user look into the directory with the hard links, he see the photos grouped together, named category. The category numbers can be huge if there are a lot of photos there. And when the time goes on and the more AI agents installed, all the AI agents update with the new capabilities, maybe new categories will create as well. And the agents on the public photos almost do the similar things, just they have different access permission. One is to the private photo directories, and one is for the public shared directories. They can add some text to the header of the photos. They can create hard links when they find the new categories, but they cannot delete the photos, even the hard links, because the hard links maybe not belong to the owner of this AI agent. Yeah. Yeah. The third one is efficient recursive access control inheritance. Currently, for the access control inheritance in PostgreSQL, indeed that's recursive in user space. The kernel space does not do that. But because we use most of the agents are third-party agents developed by others, so the user may want to try out before seriously deploy it. And for a lot of photos to assign the access control to lot of photos, do a recursive setup in user space, that's consume a lot of time. And because such a setup is performed on the user interface, for example, click the checkbox and click to confirm. Wait for 10 seconds or 20 seconds, that's fine. But if we wait for 10 minutes or 20 minutes, users may think the system is done. So the performance matters. And also when the people try to try to install the agent, all the access control need to be set up. And if the user does not satisfy with this agent, they need to delete. So this kind of access also need to be removed from all the files. And unlike the legacy NAS storage, for the legacy ones, when the file is stored on the device, his permission is very rare to change. The access permission is very rare to change because the structure of the organize does not change frequently. But in an AI scenario, it's very frequently for people to uninstall different AI agents. So it's quite frequent to change the access control rules of a mass number of photos. That's different. So the performance in this scenario, performance really matters. Okay, this is the last one. The last one is the path-dependent access control. This one is not part of the ECL, neither POSIX ECL nor the REACH ECL. It's a access control extension from us. That is for individual file. If the AI agent access the inode from different path, they will be granted different permission. This is very useful when we deploy multiple AI agents developed by different developers, and we want to combine the AI agents to achieve some complicated goals. At this moment, we found that the challenge is in the VFS code. That is, when we check the permission, we have the inode to access, but we don't have the reference to the path where the process just access this inode by the entry chains. We don't have this data structure, and all the code does not support to access this structure. I feel that this is not, there's no challenge, technical challenge, no, just coding. Yeah. Just the kernel code need to send this path as a parameter. Yeah, please. Microphone?
I beg to differ there. I think the problem with doing path-based stuff like this is that it's racing. By the time you resolve the path, and I know that path will change. And so, you're trying to do path-based access control.
It's fine. It's just because the path won't change when I hold the path structure to access the file. That's very fast.
Another idea is to use snapshots to have each agent run the snapshot.
Yeah. Something big and immutable.
Yes, exactly. Because that's something that I believe you should be doing anyway, because there might be multiple agents running at the same time. And each of which might be modifying the file underneath the other agents or the agents. Counter the right. So we use snapshots here. It's probably a good idea.
When we try to do the challenge, and we find that, there is a project named REACH ECL, which was rejected 10 years ago. And fortunately, our current request, most of our requests covered by the REACH ECL. But this is just a start. More and more complicated access control requirements will come. But at this moment, we have I just try to digest. We have 4 requirements, and with the 4 requirements, we can continue to build our system. Without it, we can survive, because the whole story, is built based on this kind of permission control. So for the last one at I cite, it's not part of a REACH ECL, but we need to patch. We need to change the file system, and this change modified the kernel API. So it need to get agreement from the maintainers. But for technically, it's not so difficult. But just a lot of change the core code path, add parameters. So it depends on whether the core developers like this idea or not. And for the rest, they're just a subset of REACH ECL. So my purpose here for this talk is just express the requirement to other developers, because the 10 years ago when Rich AL was rejected, the main concern, one concern is too much change to the core part. Another one is there is no real use case. If there was no real use case, why we do such a huge change? So what I want to spread here is just at the beginning of this year, because some huge AI model were open sourced, so many startups, many companies start to use such kind of open source AI models on their own product. So the change of the home used NARS, people will see more and more. We are the first one spread this kind of requirement on this conference, but more and more you will see that the voice rise from industry.
So I'm just curious, which is, especially with respect to the path-dependent access control, did you take a look and see if this was something that you could at least prototype using the LSM hooks?
Sorry, the last
the
question.
LSM, lake security module.
Okay, this is why I left so much time. Next page. Okay, let me see. Next page. This is the workaround in industry. And before this talk, a lot of people ask me, why don't you do this? Why don't you do that? First, eBPF. Similar things to LSM, similar to net rule-based. eBPF, the people suggest us to use the eBPF hooks and rules to do the permission check. Indeed, that we use this. But from the practice, it turns out that it does not scale. Because that's rules-based. And someone also suggests us, no rules. You can use regular expression inside the eBPF. We answer that we don't want to be a company to write the regular expression engine. We build the NAS not to do this kind of stuff. So first, the rules are not so easy to manage and persistent. Load or release, update, check, not easy. And the performance is not so good. And another challenge is if we want to do the permission check inside the eBPF rules, we need to permit all the access come into the location where we place the hook. So we need to release the DAC permission. That means people will see all the files have the permission bits at 777. Otherwise, maybe some permission will be denied directly at the legacy DAC bits. So the users blames us. They're stupid. Look at your photos. Is 777. What happened there? This challenge. Another challenge is the application. The applications have no idea what the permission they have before they accept or deny in the kernel rules. So they don't have any idea what the permission they have. But similar things like LSM.
I will note that even with POSIX examples, applications that don't know how to query to look for the apples will get confused if they only look at the mode bits, right? So at some level, anytime you try to extend an access control system to be anything more than the 12 bits of the permission mode bits, whether it's rich apples, POSIX apples, rich apples plus path dependency rules, applications that are only looking at the mode bits are going to be confused.
Okay. No. Because we for the NAS storage, we don't care about the compatibility. So for the specific volume, only one echo works. So we don't need to take care of what.
No, I know, but what I'm saying is that your argument that, setting the mode bits to 777 will confuse users and applications, they're going to be confused if all they look at are the mode bits anyway. That may not matter for your particular use case, but the argument that, your first two arguments, I think, are reasonable. We can see whether or not we should address those. But the third, I'm just a little puzzled by, because rich apples have the exact same problem.
Which one?
The fact that setting the mode bits to 777 might confuse applications, right? Because if applications are only looking at the mode bits and are not aware that rich hackles exist or POSIX hackles exist, they will get confused. That's just the nature of the beast.
Let me try to understand your question. So your question.
I'm just saying the third one I don't think is a particularly strong argument, right? The first two, I think are very reasonable arguments, but the third is, I believe, the third objection is one that is also applicable to rich hackers.
Okay, but how about the explicit deny?
Sorry?
Explicit deny. The explicit deny. That means even the group or the whole path commit the access, but for some specific reason, I just explicit deny a specific user to access this file.
I mean, look, anytime that you have something which is different from the mode bits, right? Whether it is SE Linux or POSIX hackles or rich hackles, users and applications will get confused, right? That's just inevitable. And I think that's we've lived with that. Right? So that's why I'm saying the argument that eBPF hooks and LSM hooks are not a valid solution because users will get confused by the mode bits are true for rich apples as much as anything else. That's all I'm saying.
And also, we need to modify the application. I mean, if user reach ACL, also that's a huge lot of effort. So similar thing for the LSM. As I said, we tried that. So for before this talk, in the past 2 months, we received a lot of suggestions, and we tried. Most of them we tried, and we found that maybe sometimes it might be possible, but too complicated for programmers, too complicated, and very easy to, how to say that? Maybe it works, but how can we evaluate the security? It's so complicated, combined together to achieve a single rule, but if something changed, we're not sure whether there's any security issue there. And we know that some companies use eBPF just at this moment, for example us, but we believe that at most 1 year, it won't work in practice because more and more data stored in the user's NAS, very slow and ugly, and similar things for LSM hooks. And some other vendors, they use their own implementation, not open sourced. I don't mention that, but before I come here, I asked some of the famous company provide the NAS software and the box together, the vendors. I asked them, do you have a challenge for the ACL? All of them answered yes. And I asked if upstream kernel may provide something to fit the requirement. Would you like to upgrade your kernel to use that? The answer is yes, they want. So we don't care about the big names with the private models. So we just want to make the benefit for the company who want to use the upstream kernel, use the unified implementation.
You mentioned that. It's better on Windows host. Because of that.
Windows. Windows.
What are that?
So I'm just thinking, if you guys have some this, if you did the exact same thing as Windows, someone could use it, Wine could use it, the NTFS could use it. So that might be the way to get upstreams.
But this is motivation for us. Maybe, but this is not the motivation from us. From us, the motivation is we have many third-party AI agents developed by different peoples. We need to restrain their access control. Yeah.
If you just have something that you can use, nobody's going to be interested. We can have 3 major projects that are just a couple of Windows does.
Yeah, but that rich apples were copying what Windows does, except for path dependency, which was considered a step too far.
I'm saying you can do exactly the same.
I mean, I think the general challenge with rich apples, if you go back far enough, is that the people who cared about Windows compatibility and the developers who needed to do the work didn't have an adequate overlap. And so I'm sure there are NAS boxes that would be very, very happy to switch over, or just simply do what Samba does, which is implement the Windows semantics in user space in the Samba process, right? I've talked to Jeremy Allison. He would love to have something like this in the kernel, but none of his customers were willing to fund the kernel work, right? And so there is a very, very large amount of effort that gets imposed on the VFS, any of the file systems that elect to support rich apples, the file system regression tests that would have to get modified. There's a huge amount of work. And the people who would do that work, their companies don't care about it, right? And that's ultimately, quite frankly, why Rich Apple died, is that, it's a huge amount of work. And by the way, there's a huge amount of complexity in Rich Apples. And so to say that, the security problems go away because we're using Rich Apples, it just means that the headache of dealing with potential security vulnerabilities fall on the core VFS maintainers and file system maintainers, right? So,
well, one of the main problems with Windows Apples is far too complicated and everything security problem itself.
Very easy to fill the apple as holes.
Yeah, I mean, for all we might know about Project Apples, I think the simplest is a virtual.
Yeah, I mean, I think one of the other potential issues with rich apples, at least implemented the way Windows does, is that the size of the rich apple can very easily exceed the maximum size of the extended attribute that many file systems support. Because, I've talked to some of the Windows people who were doing Windows apples. They can be a megabyte. Per file, right?
Yeah, and indeed that we don't care about that at this moment. For us, we care about how the photos, indeed not only photos, but I can give the example for photos. The photos can be processed by the non-trustable AI agent and shared with different peoples, how to control the access in very fine grind level. That's what I care about. So Windows, no, we don't talk about that. This is why I said that revisit it 10 years ago, not for the old reason.
Yeah, no, I think the only reasons why we are talking about Windows is if you combine rich apples and path-dependent access control, you get the Windows Apple system. Because rich apples were in fact copied from the Windows Apple system. And the one thing that rich apples didn't have, because everyone looked at it and backed away slowly, was path-dependent access controls. And that also is in the Windows access control model. It's just, even back then,
I'm pretty sure Albiro just sort of said, no, that's never going in, right? So, but that's why Rich Apples didn't have that. It was otherwise a faithful copy of the Windows Apple system, because the whole point was they wanted full compatibility with Windows for applications such as SID servers, Samba,
And FSB4.
Yeah.
FSB4 has apples that are patterned after Windows apples, but they did not have patterned apples. It was all I So the rich apples actually were mostly patterned to allow for us to do proper FSB4 access.
Another alternative, if you want to kernel reduce views, it has to get views doing your access control.
Sorry?
View server doing the access control.
Okay. Yeah, okay. Already asked the question. Performance issue. And someone also suggests us to use the fuse bypass, but the fuse bypass does not help on metadata. So we try that.
Why do we have to have the ACS in the first place? Is it to share the files with the AI with the trust?
Let me try to repeat your question. Do you mean the why to share this kind of photos?
So you could phrase it like this.
Sorry.
Yes, one.
Okay. Just at this moment, we found that many people like this system just because we provide a very positive emotion value.
Okay. The question is, could you do something like a snapshot of the file and share those files with the AI, which will be like quite efficient, and the AI modifies it, you don't care because it will delete it right afterwards after you share it with the AI.
Sorry, the echo. I come to you. The microphone does not work.
Share it with the AI for copying and do the scanning, and afterwards remove the whole snapshot of the files. So you don't care about ACL and everything, just to share with the AI and nothing to modify or look the other way.
Because the results will be persistent. The results for others after the loop of the AI agent process the photos, they will generate something we call category. That means some more interconnection, maybe emotion, maybe food, maybe location for existing photos. And these stuff will be shared, recommended and shared to other users. They need to stay there.
So you say that the metadata.
At this moment, we use a Harmony. And which kind of media? The category.
But this is given just
That's the I use. There are people watching.
Oh, okay.
Okay, just the echo. I can't answer you immediately here because AI agent was not developed from me. But what I see that it depends on the developers who write the system. And before you give this suggestion, we try something. It's not so easy for software developers. But I for the ref link, it's fine. Just we don't use ref link just because it occupy too many space. And this one. And for the metadata, we don't want to invent or even some specification for AI agents to manage complicated metadata. Yeah, because this kind of AI agents are not developed by us. We can build some quite simple specifications, but we cannot give too much restriction, at least at this moment, to other third-party developers.
Yeah, also I think based on his question there, I might add, now you have this, he said that why would you use snapshot kind of copy to the data for temporary use? But you said that because you are going to generate some more information, inject to this exact file hardware. So why don't you set up a fabric kind of like you said the category of some cache system there to see all these kind of category information and
it's possible. It's possible, but that's not the root issue, but not the root issue. Yeah, it's possible. But it's fine to modify the file. Even, for example, at this moment, we directly remove the photos which contain the face of the face owner. Maybe in the future we can add some mask on that. So it's fine to change the photo, but delete it is not permitted.
I have some more questions. So if user A upload a photo, but user B modify it, it's a malicious.
No, the won't happen. Won't happen.
So if another question is if the user A change the photo, he can reverse the change.
Reverse which kind of change?
I mean, fall back to the version 1. If we add it to version 2, but I don't like it.
That's application. That's application specific issue, not the access control. Yeah.
Thank you.
Yeah, we have made.
Yeah, so we have
3
minutes left.
Okay. Yeah.
So I just want to make sure if you had more slides or
No,
points you want to make.
this is the last one. Yeah, it's desired to be upstreamed. Currently, most of the vendors in the industry they do want this feature. I talked for 2 famous vendors that I know, people I can talk to. Yeah, so this is not a single case from us. That's industrial agreement.
I have one question here. All here we talked about the rich echo here is designed by your specific user case here, and we see the benefit. I'm thinking about the other way, what's the disadvantage here? I heard that you said the reason you don't want it.
Okay, the disadvantage, most of the disadvantage is a lot of effort. But before that, why we do that without any real use case? But at this moment that if the core developers upstream, they have interest to reactivate this project, yeah, we would like to support them. Yeah, we can join the development, join the testing. But what we worry about is we spend, for example, 2 years to make it workable for upstream kernel again and reject it.
I'm not sure, is there any I'm not expert at all. I'm just curious, would this one, we have more information there, would it affect the base cast or kind of loading? We kind of move the file from disk to memory.
That's possible, but still, back to the root case. And the last sentence, if there are upstream developers have interest to take it back to upstream, we can bring up some positive emotion values. For example, support your overseas conference whole year, something like this, with business class flight, something like this. Yeah.
All right. I suspect some of those discussions may be better done offline.
Yeah.
And we're just about out of time. So
yeah. Thank you. Thank you all. Yeah. Thank you.
Your slides. There it is. Yeah. There we go. Yeah, no, it's no. We're right about on time. Yeah.
Okay, so
Yeah. Yeah.
Okay.
Yeah. So our next talk will be about revocable. So why don't you take it away?
Okay, and hi, my name is John Lee, and today we are going to talk about revocable, a new proposed mechanism for preventing common and troublesome type of bug. I also call it classic use after free. So what exactly is a classic use after free? Here is a typical scenario. Let's say we have a driver provide a certain resource, and a second driver relies on this resource and is posed to user space via an interface like a character device. A user space program can then open this file to use and access the resource. The problem starts when the provider driver is unbound. So, which might happen if a device is unplugged. And when it happens, the resource is also freed. However, the user space program is unaware of this, and it still holds what now is a dangling reference. And a subsequent operation on this file could cause a use after free. This is not a new problem, so there have been some related works, and this work is essentially a follow-up from the latest one, and we use the same concept and the terminologies. So the proposed mechanism is it introduces a new additional layer of interaction to access the resource, which allowing us to establish weak references to the resource. But the most importantly, it's decoupled the two independent life cycle. One is the resource and its provider. Another one is the consumer instances. So with the interaction in place, it remains a valid operation when we want to access the resource, even if the resource is gone. And instead of triggering the fault, it simply returns a null to signal the consumer that the resource is no longer available, which allowing the consumer handles the situation gracefully. It is common from the community mailing list to ask about what is the difference between device resource and revocable. Device resource, aka DEVM or device management, is designed for preventing resource leaks by automatically releasing resources when a driver is unbound. On the other hand, revocable is focused on preventing invalid memory accessing by invalidating access to a resource when its provider goes away. So actually, they are independent mechanisms, but they can certainly be used together for more robust resource management. Let's get back to see the proposed mechanism. It introduces the two types of handle. One is the provider handle P here, and it is actually a reference counted object which persists as long as there are consumers using it. Another one is the consumer handle C here, and it is it has the same life cycle with the consumer instance, meaning that it is always available to the instance. Synchronization between these two types of handle is a key aspect. So here we have a single writer, the provider, and
it should only write once when the provider decides to revoke the resource. And we have potentially many readers, the consumers here, and they are frequently trying to access the resource. So this is infrequent write and frequent read scenario. For this scenario, SRCU or RCU are excellent fit and highly efficient fit here. Here we show some example scenario. So in this diagram, we have two consumers, C1 and C2. The consumer can enter the recite critical section and get the pointer of the resource and perform its works. But in parallel, the provider can decide to revoke access. After that, any new attempt to try to access the resource will receive a null. However, for the existing consumer, it's still in their recite critical section can still use the resource. The revocation is complete by ensuring that all readers exit their critical section. And actually, this is these are guaranteed and offered by RCU. So now let's briefly look at the implementation. So the provider handle contains the pointer to the resource, which is protected by RCU. And the consumer handle holds a pointer and the reference count to the provider. So it generates a particular tree. We have one resource and one provider and potential multiple consumers. Here are some core API functions. So the consumer uses the try underscore access to enter the recite critical section, and the RCU dereference the resource pointer from its provider. And on the other hand, withdraw access to exit the recite critical section. The provider can use the revoke function to mark a resource as unavailable by setting the pointer to null and call the synchronized underscore SRCU by ensuring that all readers exit their critical section. So here we are show you some real-world case study from Chrome OS embedded controller drivers, and we observed that there is the classic UF in the drivers. So it's actually it allocates a DVM memory area in its probe function, and after the driver is unbound, the DVM of course will be free. The problem was that there is a character device exposed to user space and stores a raw pointer to this DVM memory. So after, if the provider driver is unbound, the pointer here is left dangling. So subsequent operation on this file could just trigger an UF. The first solution comes out is to use the revocable API directly. Instead of storing the raw pointer, the open callback function allocates a consumer handle. Any functions that needs the resource need to secure the access by using the consumer handle. Actually, we landed this solution to Chrome OS downstream kernel, and per our observation, it works well. But after this solution was sent out to mailing list, I received some feedback about we probably don't want to change all of the device driver like this, which is too verbose. So that's why we have a second and more ambitious solution, which is to automate the process by replacing the file operations to some wrappers, and the wrappers can then secure the assets before going to the original file operation. Comparing the two solutions, so using primitive API gives us the finest grain control over the critical section, but it does make the code verbose. Replacing the file operation is much simpler for a driver author, but it is more a coarse-grained lock. And also that there are still some open issues for with the replacing file operations, such as finding somewhere to store the replacement context. To sum up, so I think we shouldn't take the two solutions as exclusive. Instead, because that the primitive API usage will be there anyway, and it is ready and also tested. But we are still on our way to figure out approaches for integrating the new proposed mechanism to subsystems. I think that concludes my presentation, and I will be happy to take questions.
So I get it that you still figuring out, but just want to get like deep review. What problems approach when you appear when you just try to apply this to a whole subsystem? Which subsystem are you testing?
I guess the microphone.
You try this remote with subsystems?
Actually, that's a MISC device.
Funny that we have a conversation with the radio.
Just hold it really close.
Yes. Yeah. So it's been a recurring conversation. That's an interesting approach. I can see it being useful for all of those USB-based things. And so that being useful SRC and slaves are related quite flexible. Only problem would be some cases of location. That seems to get a little bit. So I do agree that we need something similar to that, but most, you focus the first slides on user-space consumers. You have user-space processes, accessing resources through IACDL, for instance. But we also have a bunch of resources inside the kernel, GPIOs, for instance. As an example, where the consumer can be just inside the kernel. So first of all, I don't think this is specific to user space. So having a generic solution that can handle the GPO case, the GPO provider disappearing, and then all of a sudden a driver that tries to control the GPS won't be able to do so. We need something. However, when it comes to user space access through MISC devices or character devices in general, I think that we could handle that at a seeded level, character device level. The Apache that they posted several years ago, actually, that's, to my understanding, in my testing worked properly. And I don't understand why we need to introduce this, where we can handle that in a way that's basically transparent for drivers if we handle it at the seed level.
So, to make sure I understand, so your question is that why we need to use maybe the first solution instead of going to the CDIF level?
First or the second?
Why do we need a new mechanism like that when we could implement that at the CDEP level without having to introduce this whole revocable infrastructure? This is useful for internal consumers, but for user space consumers through character devices, I think we can do something that's simpler and also easier to understand when it comes to lifetime management.
So I guess that because we have I guess we have a similar discussion on the mailing list, and I don't figure out a way to maybe just have a simple solution to fix at least fix our issue by some simple patch to the CDIF level. And that is I guess the most crucial way is that here the consumer handle should be the same life cycle as the consumer instance, which is the structure file. And if we want to put it into the CDIF, I guess that CDIF will be shared by multiple files, so it cannot contain maybe a file specific or file instance context layer.
So I was going to make the observation that the technique of replacing the file operations is actually something that the TTY layer does already to implement hangup, right? So in that particular case, it's not that the device is going away, it's that the carrier detect RS-232 line has dropped. And so therefore, what is desired, what is actually required is that all reads return EOF and writes return errors. And so the easiest way of doing that is to essentially swap out the file operations with a TTY hung up file operations. And that's actually a very, very similar technique to what you are doing. They don't have to do the ref count aspect because it's not that the device is going away, it's just that the modem is hung up. But it's actually very, very, very similar. The other thing that I would note here is that the BSD operating systems have a revoke system call, which allows you to essentially do the normal equivalent of replacing the file operations on any file descriptor, so that reads return EOF, writes return errors. You have to figure out what you do with MAPs. But if this is actually interesting, I think, to a number of situations beyond character mode devices. Because if what you have is a file system and somebody yanks out the USB drive, today we don't get use after freeze because we don't allow the device to get released. However, you get a whole stream of errors to the serial console because any attempt to read or write to the device returns an error, and then you get all sorts of errors from the file systems that go all over the place. One of the things that people have talked about wanting for a long time, and it's a very related problem to what you're doing here, is a way for the block device to notify the file system that the block device is gone, and then the file system would effectively call revoke on all of the file descriptors that are open on that block device. So again, reads return EOF, writes return errors, so that you get a much cleaner situation when a device goes away. And so I think if you think about this from a broader perspective, you might find interest in the community because you can solve a larger set of problems than the specific one that you are solving here, which is why I think your approach of trying to swap out the file operations is actually a very interesting one. And as I said, we sort of do that already for the TTY case, and it might be interesting to see if a more general solution might allow something that would also be usable for the TTY hangup case. So that's something I'd encourage you to take a look at.
It's a little different for, in your case, you're replacing them with virtual terminals at the point of hangup. In this case, wrapping them that on every access is going to check for failure. And probably increase all parts there is a distinction between the two cases. I think this is more interesting as an income than the only problem we saw here was the classic part of inheritance. For example, error and everybody has a version.
But if you're done, there's the next one.
People should have listening to what you described, but the thing with IPC or GPI was that he had a layer up below USB, which didn't even know that it was on a USB, and this basically something that was never made to survive a sudden detach, suddenly being detached and crushing. And I'm not sure if that would work because I haven't closed my eyes, but I remember that we don't really keep track of the file descriptors as such, and when we are detaching their, I don't remember exactly what it was we were doing, but I think we don't have the handle to just replace the operations like that. So this is why we almost suggesting to fix it at the primary device level.
I also agree to make it more generic, you should really follow the path of like converting a subsystem to use local. And I would volunteer with I2C, which really suffers from that problem, to like a system that conversion. And if you get a subsystem to use revocable for better, then I see both revocable get better and these are get better at normalization. So to get a bit away from this one driver, one parity device scenario to like this two-zone usage. Yeah, I think that would be a very good next step.
Another comment is regarding the difference between internal consumers and user space consumers. I think that, correct me if I'm wrong, but from what I understand, when a consumer wants to acquire a resource, it will have a critical section at the end of which it will have to then release that resource, right? So from a user space point of view, if you consider that you want to prevent access in the release function, so when user space closes, we don't want to have a resource where the critical section will start at open and would end at release. That would be way too long. We do have cases that we've seen with user free when you close a file, where we need to ensure that when you disconnect the device, you free memory. If you free memory at that time, the same memory won't be accessed at release time. But you also need to consider the fact that there are, so the two cases are keeping the file handle open in user space. That's an operation that can last forever until user space decides to close it. The other one is IOCTLs, or other system calls that are in progress while the revocation occurs. In that case, I think that you have a critical section that's fairly time bounded, but for the open to release case, then that's user space deciding how long you want to hold on that resource. And I think having the repairability for that would be a problem.
I mean, I think the issue that you are concerned about is solved by using RCU, right? Because if you use RCU, essentially what you do is you replace the file operations with the revoked file operations. Now you wait to make sure that all of the CPUs have actually scheduled, at which point you know that you don't have any internal IOPTLs or reads or writes taking place. And at that point, you can disassociate the file descriptor from the underlying device. Now, it does mean that you have to be able to find all the file descriptors that might be associated with the device that you want to have go away. But I'll note that any of these changes, right, even using the new revocable structure, is going to require making changes to the subsystem, right? I think that's inevitable, but I think it's a good thing to do. And if we want to have subsystems that now have to deal with this brutal cold world where users can yank, your GPIO device out abruptly, it will require code changes, unfortunately.
So I think that's a good point. My goal here when it comes to user space consumers is to make sure we minimize the amount of changes to drivers. Making changes to subsystems is absolutely fine.
And we most likely need some changes in the drivers as well, at the very least for drivers in the remove function to notify the subsystem that remove has started. That's a given. But I don't want to do more changes than that in drivers. RCU is, I think, a fine solution for that, and the battery load was to fix that at the CDEV level with some help with the subsystem load based on RCU. So I think that works. It's been tested. And yeah, so if we can minimize the changes to drivers, I think that's a good goal. When it comes to internal consumer for GPIOs, for instance, then the changes will need to be done on a per driver basis. Every time a driver with access to GPIO, that's the consumer has to be changed to acquire the resource at that point. But for user space consumers, I really would want to minimize the changes.
This is just a random comment. Not particularly about your work, but consumer-producer pattern doesn't really work really well in the kernel all-day cases. One particular case, and we know from past experience, suspend. Like when your consumer waits on producer in uninterruptible, unfreezable state, or producer waits for consumer, and then you freeze them in random order. Sometimes you just cannot suspend the system. So extending this consumer-producer patterns into more subsystem can be a little bit problematic. There can be dragons.
Any other questions or comments?
Oh, okay, and I have the last slide. Thank you for your time.
All right, we're at a break, I believe. Yep. And we'll start off again in a bit over half an hour. I know that Susan worked in the rich capital package and how that changed for a number of years. But as I recall, right, so the rich capital package said it can't be upstream until someone updates it to the most recent version. Have you done that or have someone done that? Oh yeah, Bob. Well, I mean, I think the
So I agree that there will need to be user space changes that are done before it is activated. And in fact, a related question I have is if we just got rich Apple passive upstream, but we don't have the passive changes done, right? Is it useful to do? Because I think it's going to be easier if we can do it in steps, but is the first step by itself, rich Apple, is not useful until you also get the passive changes. Yeah. Yeah, I mean, so here's my thing, which is the first thing is to get a rough sense of how much work is it to get the rich active patches, the last version. Yeah, right. We adapted so it can apply to it. I don't have a good sense of whether that is, 2 weeks, a month, 3 months worth of work to get just the access to it. Because, and then by the way, the other thing that's interesting was there was one or more rich actors that have also been. That's probably easier to resurrect if you just find, the old, an old Git version of those patches and restore those patches, right? And fortunately or unfortunately, right, the kernel community is unlikely to make a commitment to, accept the patch until they can actually see that patch in its final state. Right now, I would certainly recommend that you not invest effort in user space changes until you find out whether or not the rich patches will actually get in. Right? But in order to do that, we have to actually update those patches. Right? And again, I don't have a good sense about whether that is, a month of work or 3 months of work or what it is. Someone's going to have to look at it because it's been too long, right? Yeah. Because I think the standard approach here is, updating the patches in the latest upstream version, send it out to the FS developers, saying, we have an interest in using the rich Apple patches. We have an active use case, right? You can point at a recording of this talk, right? Because all these talks are recorded, they'll be up on YouTube and say, for more information, this is the quick thing of what I'm doing, and you also view the YouTube video if you want to see the fuller explanation of why we want it, right? And then you can say that, we're willing to, invest the effort to actually make that work, right? And see if we get a positive response from those patches. I'll be honest, I have not looked at those patches in many years, right? So I certainly can't comment on how suitable those patches were. I don't recall anything really objectionable. I think it was mainly an issue of, again, how many people would be willing to, support it in terms of the additional work that would be needed for their file system. Right now, one of the advantages of both the Posix Apple code and I believe the rich Apple code is most of the changes are in the generic DFS link. There's very little changes needed in each specific file system other than the extended attribute storage of the rich Apple, right? So the changes in EH34, XFS, ButterFS, etc., to support your tackles is, if I remember correctly, very, very small. So I suspect that if
there is VFS test support, and someone is going to get those patches into a good shape, we can probably get an answer to the question, is this acceptable? And, you know, as long as someone is willing to be the, you know, long-term maintainer of Rich Apple, right, just like Andreas Gruenbacher was the Closet Apple maintainer, I think it's a reasonably good chance we can get that up straight, right? I can't promise anything on behalf of the entire community, but that would be my recommendation for the next steps, right? And I hope that that's, you know, less than 3 months worth of work, right? I don't know for sure, it could be much less than that, it might be a bit more. Maybe more. Yeah. Maybe been that long? Okay, yeah. Yeah, well, yes, it has, yeah.
And that means that needs
Yes. Well, I mean, I think the Rich Apple code, I think the general answer there will be the changes that, you know, that will be present regardless of whether Rich Apple is enabled or not. If they're small, right, the worst that will happen is, you know, people will just simply not enable Rich Apple. Compile time, right? So if the risk to the code base, if Rich Apples remain off, is relatively small, then maybe people will not hear that much. Now, when they enable it, if it causes a lot of, you know, KSAN failures, sysbot failures, whatever, right, then we just have to make sure that the failures are assigned to the Rich Apple subsystem. And then it's the problem of the Rich Apple maintainer to fix the bugs, right, because it's in the Rich Apple code. So I think in general there, as long as it doesn't, you know, cause maintainability issues to the core VFS, you know, without Rich Apples applied, right? Rich Apples, you know, it's like fs rich apple.c or something like that, right? The core maintainers don't necessarily need to look at it, right? It's sort of like quota, right? Jan Kara is the quota maintainer. Most other people don't worry about quota because the quota code is well isolated from core VFS and from the low-level file systems. Right? There's a little bit of support because we have to actually notify the core subsystem every single time we allocate or deallocate a block, right? But most of the complexity there is actually in the core code. Yeah. So it's fine because most people, you know, a lot of kernels just simply don't enable quota, right? Because, you know, if you're in a you know, single user desktop or a single purpose server, you probably don't need quota, so you just simply don't enable it, right? So I think the argument that I'd recommend making for VFS is, look, you know, we're on the hook to support Rich Apples because that's what we need. And if you turn it off, the changes that actually apply to core VFS is probably just, you know, a couple calls under a misfit, right? So the risk to core VFS is actually very, very small, right? You would be asking for the core maintainers to review it to help you find bugs, but the ongoing maintenance of Rich Apples to other file system developers would be very, very involved, right? So that's the argument that I would make, you know, when you're sort of, you know, trying to persuade people to accept the patches is, you know, look, we have a use case for it. This is not going to really increase the work of other file system maintainers or EFS, right? We would just simply like to get this, new feature upstream because we have a good use case for it. And then it may very well be that people like the NFS4 folks would say, oh yeah, we actually like to take advantage of the rich Apple support so that you can actually provide the NFS4 Apple functionality, at which point they will be helping you find bugs and clean up any, issues with the rich Apple code because they would be using it as well, right? And at some level, that's the whole benefit, right, of open source development is that hopefully there will be other people like the NFS4 folks that would also find this code useful, and so therefore they will help you find bugs, etc. Right? So I think that's the approach that I recommend, right? And I would recommend not introducing the path dependence piece until the rich Apple piece is landed, right? And I think the risk to you is, I think the path dependent feature change may be a harder one to do. And so that's why I asked you the question. If you only have rich apples and you don't have the path dependent piece, is this actually still useful for your product plans? Because it may be unfair to ask you to do rich apples if it's actually not usable until you also have path dependent access to this, right? Yeah, no, that's fine, right? I think you need to think about that, right? Which is, because rich apples call it a year, realistically speaking. Right? I mean, it might be a little bit shorter, but the reality is you probably want to wait until the next LTS release before you actually use it to real, right? So, we're, figure on, hopefully we can get it landed in, I'll say 6 months, do a little bug fixing, and then the 2026 LTS release is when you might be able to use that as a product. But then the path dependent piece might be right? I'm just being honest with you, right? And I think that's going to be the harder piece. Yeah. Well, so the way rich apples work, right, is it's like positive apples, which is you land the rich apple piece and then you also enable it in, I would say, at least 2 or 3 other, 2 or 3 file systems, right? XFS, EXT4, ButterFS, say, or EXT4, XFS, ButterFS. Honestly, there aren't that many file systems that actually enable positive apple generally. It's actually not all the file systems, right? And that's okay, right? But the actual changes for the other file systems is actually very, very small, right? Because it's just supporting new extended access, right? So, the rich apples, might be 15 patches, and then you would have one patch to allow EXT4 to use rich apples, one patch to enable ButterFS to use rich apples, etc. Right? Because again, it's just the extended attribute piece, and then in the permissions check code, a call to say, is there a positive tackle? Yes, call the positive tackle, check permissions, right? So enabling a particular file system is not hard, right? No, it's not. it's fairly easy, right? So, yeah, I mean, that's, again, I think if you can get the core rich apple code in, with at least one file system using it so that people can actually test that code and demonstrate that it works. That, I would recommend doing that as a first step, right? And, you know, whether you do one file system or 3 file systems doesn't really matter, because again, I don't think it's a lot of code, right? Yeah, 4-part first, and then app dependent second. But you have to make a company decision, which is at some level you are gambling one software engineer year of effort for Rich Apple without any guarantee that path-dependent access controls will land. And if Rich Apple by itself is not useful enough for your product, that's a decision only you can make about whether you're willing to invest a year of software engineering time, right? Yeah, that's, I can't make that decision for you. Yeah. Okay, all right, yeah. I mean, effectively, you have to show off the VMA so that any access to that memory region becomes a C++. Yeah. I mean, what else are you going to do, right? The device is going away. All right. You know, I guess I could say that. So I'm going to talk about this because that file system regular file, so that's like easier, right? Which is if the pages are ready in speech access stuff, right? Then you could potentially allow read access and just simply stick up on the right. But the problem with that is it's very, very limited because not all the pages may be identified through the references, right? So this becomes a design question, which is do you allow the application to run as long as possible, so long as they don't try to modify any of the memory and they don't try to access a page that was never alternated, right? Or do you immediately, kill the process the moment it tries to touch that quicker in that DNA at all, which is easier to implement, right? Because you essentially, say, all right, I'm going to unmap the DNA and then kill off all the page tables, right? Otherwise, you need to keep the DNA around, and then the DNA needs to know that I can't actually, allow any write access. It can be done to work. Right. And then I guess there's a third option based on most which is any process that has an that region to a device which is disappeared, you just kill the process right away. I don't recommend that. I'm just saying that's a third option, right? Yeah, and that's why I had my I'm not sure actually which is the best. They all have strict off, right? And depending on the application programmer, they may have a strong preference one way or the other. Yeah.
find that. Well, yeah, it is. It is.
Yeah, so it's not, it's just, oh wait, no. Oh, no, yeah. Oh, I see what happened. When I refreshed, it now says now, and now it shows. Okay, that's what yeah, so I had to refresh from the morning, and the morning, I think it just ended. Yeah. All right. Yeah, I just panicked for a moment. Figure out, say, I don't have to do it. So you that's a big change. So we get access to them to that. If you can't do anything work, you become busy or you become a very, any kind of person become busy or you but it means the further support and you can kind of work on. I mean, if you're saying it's not solved, I can good. I don't know which is also criticism.
Yeah, complexity rises. Complexity has been. Big future market. Hopefully. Just a good, if you look at yeah, especially certain. It depends how well, most people would yes. But you would reach the session. Yeah, it's whole and still kind of tends to develop once every 10 years. He's at I'm a good friend of his. Like I told you, I remember how there was a long discussion. Because I know at one point it was like, maybe we will allow our exchange, but I think it's kids. It's next about to there. He and with my manager and the living airlines exposed them just do some conference with their personal space and so yeah they they're good friends. They come to a company with this. I thought, yeah. And good. You must respond to it. But that's good shit.
Clearly, this is that's not negative here.
That's it works, yeah.
Why is that a problem?
I only draw about that because I can't convert this one. Yeah, it's like that. But then this is the best this one, like they got so many components inside. I have one to order the three No, when I joined it was still there, like, also the same thing. Everything even working.
Yes. The other nuance
Okay, yeah.
I don't think people like yeah, many people like I was wondering about there's one fighter.
The last user,
And after that, it's
I never say my solution did not finish. It's the same thing. You get somewhere. And then yeah. Oh, I got this. I got the second small. Like this. Yeah. It's already maybe try
So I
with absolute So that I would say it's not the great things.
What I figure out.
These seeds so instead, you say, then you work closely with them.
John, there are a couple other folks in the system. Yeah, the I asked Scott, he said that's how we're going. I think
when the GPO system,
yeah, it's good.
that is a solution that's easiest to understand. And try to understand that the structure will lead into the last structure.
He also said so you're also I think you must have done that on purpose. Yeah. Yeah, I think so. In the press release, he said something like it's normal function. Yes,
Or that to change it. They don't. So I was happy with the government. But you have to follow. I mean, policy kind of everyone's considers what I think. Each player can just like that, my down list, like this is what I want. Everyone's getting out of it. Like at a certain point, what am I going to do? So I didn't like it, but I respected it for a while. Oh, yeah, yeah. Yeah, I heard that. I did 6 months ago. So in this meeting, one of those movies are Harvard or another by 40s. I did it a long time ago. What's the solution? That was one. The feeling I have right now, I don't think we could take a solution. You take over, but I the feeling that is thought is that it's it was supposed to be here. I know that it's not good. I was looking forward to seeing it. But after Jim explained himself, I did it. But I was happy with it, but I didn't understand. So after that, just and my idea was required to have to wait for a year for this to get to where every 3 months and it's all around this. It's bad for morale. I think it's better. We really have to
anything you've activated. But we actually did end up with, I didn't have anything to do with it. It was a networking appliance that's supposed to be running on two that I think most of the RT benefit they get out of running the PTAs as opposed to stuff they're doing in the LS.
So long ago, Terry and I were involved in a project at IBM, which was supporting real-time Linux with real-time Java using preamp RT for the EDX 1000 or EDG 1000. So whole classes for it. So that was many, many years ago.
That's what got me into it. Have you ever talked to somebody who's worked on that shit?
I had a friend who was, that I knew at MIT, who was one of the people who experimented on the hydrodynamic stability of the exalted class destroyers. And basically, you get seasick very, very quickly in rough seas.
I talked with one of the, so VMware had this interesting partnership with the Navy, and they bring in officers. They didn't have anything nice to say about that system.
Yeah. Originally, they were supposed to build 20, and then they had so many cost overruns that they only built 3.
And it didn't work.
Yeah, it didn't work all that well. And because they only had 3, once you amortize the development costs of their smart ammunition, it was like $1 million a shot.
Yeah.
And it's like, it was really, really bad.
Yeah.
It was like our tax dollars at play.
Yeah. But it could launch a hunk of aluminum the size of a Volkswagen 2 miles.
All right. This is the last session of the day. Thank you all for coming. So our final talk on the kernel summit track is News from Preempt RT by Sebastian. And I'm going to butcher your last name, so I'm not going to try to say it. But yeah, welcome.
Thank you. Sebastian Zivio, I'm presenting some news. I didn't bring one. How do we go to next slide?
Here we go. Yep.
And the thing was, okay, perfect. I didn't bring one topic. I brought a few ones that I or others worked over the last year. And I will present each one of them and how we did it, why we did it, and what was the effect of each one of those. Okay, so let me get to it. The first one was the unlocking of the bottom halves on Preempt RT. The ground problem was that the implementation of how we have it on RT and non-RT is quite different. Primarily, it starts that on Preempt RT we have it preemptible for more or less obvious reasons, and we can have a context switch while we handle it. Normally, all the handlers are threaded, like the interrupt handler, which means we don't have it piggyback after the hard IRQ like we have it normally. So the soft interrupt runs right after the thread interrupt comes. And normally we don't have any soft interrupts from the hard IRQ. And eventually we had ones now and then, and those were outsourced to KSoft LQD because we need to handle everything within a task context. And this was worked reasonably well. However, because the preemption is disabled on non-RT, this ended up more or less as a PCPU log for all data resources. Not on purpose, maybe, but it ended as it is. And this caused problems on RT. And as a result, we had also built in a log into local BH disable to mimic this logic. And all the BH resources which were protected via this preemption disable logic was also preempted since then on Preempt RT. So this was like the good thing there. However, we have long-running threaded interrupts or other resources, then they will block each other. This is not necessarily a problem if all of those are at the equal priority. But if they have different priorities, then one will preempt the other. And as a follow-up, they will boost each other to completion. And this is not something we can easily deal with in the beginning. The PI boost also removes the need reset condition, which we don't observe. And we could work around it that, say, if we are PI boosted, then just do a context switch to avoid the lock contention that we built into it. But this, on the other hand, leads to other problems that we have to identify all the spots that are ideal for the context switch. So eventually, this is what it would look like. This is an outlook from trace switch, where we see that networking soft interrupt got raised within the thread of the networking interrupt. And then we had the context switch over to the other one and a priority boost, because the task of the CPU at the time was the networking thread. So then we switched to HCI, which is the IO, and then we switched back again to the networking thread, because it's simply the PI boost that we had. Then the networking thread had to complete, and after that, we were able to switch over to the block IO. And this is basically the symptom, how it looks like if you see what is delaying the starting of the thread. And this is what it would look like. And so this example with the disk IO is just an example. You could also have an FPGA interrupt that does nothing else in kernel. It just do a wake up of the userland thread, where you would have all the logic that would handle it. And another example could be a CAN driver that needs to act quickly and either inject a packet into the stack or the other way around. If you audit the driver for the CAN, you could see if it needs a BH disable or not, based on the logic and on the underlying functions on it. But it's hard to argue why it's needed or why it's not needed. And if you avoid it, then you will also lose the soft IQ semantics, like core code or other parts that check if it's preempted or not, or if we are in the right context. So all of those are not sane to just work around it. And all what we do is basically have those locking mechanisms to protect random per CPU resources, which are nowhere documented but are used by certain subsystems. So what I went in 2023 at Plumbers was to sell explicit locking mechanism to the networking forks. Those were chosen as the part of the maintainers to pitch it to, simply because networking is the largest stakeholder of this. Like other subsystems, as the block IO or other drivers, are not using soft IQs that extensively as networking does. And it took a while, and I started, once they bought it, implement something that is called lock nested BH. And the way it works is that it implements on preempt RT a lock for the resource that needs explicit protection, while on non-RT it simply verifies that the resource is accessed in bottom half disabled region. And that work is mostly complete in 6.18 as of, And with this change, this is what it would look like. Like the networking driver starts, and then once the HCI driver comes in, it will preempt it, and its soft IQ will run through. And after it's completed, it goes back to the networking interrupt. So basically, what is required is that the other has the higher priority, because otherwise it will work end to end. And this was the change for most of the drivers. And this is what it would look like. This is a snippet from actual code that we have today. We have the BH lock with a static initializer. And here it has the system page pool, which is explicitly protected for RT reasons. And it's accessed via this CPU, which basically accesses a copy of it that this has been explicitly allocated for this CPU. And this is the protection we have instead of the big lock that we had initially. And most of the per CPU variables are dealt like this. There are a few exceptions, like initially I was trying to sell it to the BPF department of networking as well, because XDP was a strong user of it. But this will require mostly modifying all of the drivers that are having implementation for XTP, and they didn't like it. So instead, we went for something like this. So we have this pointer that collects all the XTP BPF related structures in one place and assign it before we call into BPF code. And there are a few spots in networking that are doing it, like the NAPI invocation to begin with. And then there are a few userland related callers like the local interface, which do the same thing in process context. And this also supports nesting and all kind of things, since this can also happen. And the task struct has this pointer. So we always have a task that runs on top of us, either the idle task or a random task that is there. So we either assign a new context on stack or reuse the already one existing one. And this went in last year, I think, in the middle or something like that. And after a while, there was a report on NetDev that this change apparently fixed use after free purely by coincidence. So once this was noticed, which had a smaller change to the stable versions of the code just to fix the use after free regression that we had for some years. Now, next thing I have is Futex. Futex is used by the glibc mostly and other code that implements logging. So the mutex itself, the condition variables, have a mutex variable in it. And this is utilized, for instance, by mutex log or unlock. The condition variable as well via wait or signal. And there is no difference from the kernel view if you use logging or a condition variable for waiting. An example would be something like this. There is a variable for the log, and there's a pthread mutex log on the thread 1. And this happens mostly if there's no contention purely in user space. The problem arises once you go on the thread 2 and you want to acquire the same log. Because since the log is acquired, you will need to spin on the log until you get it. And this is mostly wasteful resources. So to avoid it, we use the kernel for sleeping. And notification once it's gone. The simple implementation of it will be something like that. You have a variable, name it as log. And your log function is basically you read it, and if it's 0, you just assign it because you acquired it. And otherwise, you go via the Futex wait syscall to wait until its value changed. Now, a little bit more verbose will be something like that. So you read a value, and then you need an atomic compare exchange. So you switch from the 0 value, which means unlocked, to something that is locked. And if this worked, then you can return and you have your logs. No kernel interaction whatsoever. And if this didn't work because it's already locked, then what you want is you want to set a waiter bit again, which means there is the unlocking part knows that there's a waiter. So you assign it, and then what you do is you use this Futex syscall to wait. And you pass log and waiter simply to the user that the kernel can verify that the value is actually locked in waiter at the time that you go for sleeping. Because if the unlocking part managed to unlock it before that, then it will not observe a waiter. Therefore, it verifies if the value is consistent with what the user part thinks it is. And if it is, it goes sleeping, otherwise it will return. And then the whole magic repeats until we end in the upper part as locked. And for the unlocking part, this is what we would have. We would have, we expect it's locked. And if it's the case, then we simply unlock it and go away. Otherwise, we think that it has to be locked and that we need a waiter. And then we simply wake the waiter and leave as well. The 2 at the end means we wake 2 waiters. The first one will be the one that we want to have the log acquired, and the second one is simply there to have the waiter bit set again. So it's not primarily effective or intelligent solve, but it's a simple case. So basically this means userland does all the logging, whatever it means. Kernel is not involved in anything else than simply letting the task sleep or waking it up again. And this means the kernel is only aware of what userland does at the point when it goes into it, requests sleeping or waking. Log PI, unlog PI is for priority inheritance, and this works similar from the logic, which means we don't have any state other than on contention. So what the kernel gets is only the U address of a waiter. So this brings us into a situation what the kernel sees is mostly this. This is part of the structure that we actually have, and this is the part that we use for private futexes. Private means it's process local. It does not go with, it's not shared with other processes. So we have the URL, the address, split into the base address and the offset within it, and the pointer to the MM struct. Basically to uniquely identify a task, because this is then added within the futex queue. So we have a list, a task that owns, and this information is the key. So whenever we go to sleep via the futex wait or wake a sleeper, this is the information that the userland provides. And this is then added to the queue. And obviously, since we have a queue, we need to have a log as well. The log is used to race-free add and remove the futex queue items from the bucket list. And this also works as a synchronization mechanism. So whenever a waiter adds itself to the list, we can be sure that the waker is not racing against and seeing there are no waiters and simply leaving it prematurely. And since one log would be quite a lot for all the tasks in the system, this is hashed, and we have multiple of those. So we take whatever we have in the futex key, apply a hash to it, and then we pick one random bucket that the hash points to it, and then we operate on that one. And the bad point starts when we have two tasks that are not related at all and end up being the same bucket. Same bucket means that it's the same slot and the same log that we have. And as a matter of fact, it's not really reproducible which slot you end up with, because address space randomization basically makes sure that the MM pointer is always a different one, and the pages and the memory addresses within the process is also a different one. This in turn, if you block on the log, which is used for the hash bucket, it may lead to long delays within RT, especially if the owner is blocked and does not respond to PI boosts for some reasons. So there was a report from 2024 which made me work on it. However, this was not the first time I tried it, because I already tried back then in 2016. And at the end, we presented 4 approaches that we tried to have, and each one didn't work for various reasons. And we did learn from it, however. So one attempt was something we called futex attach back then. So instead of passing a U address, we had a cookie, and the cookie was processed local. And this was all race-free and was contained to the same process, which was good. However, this required that the users, like pthread mutex init, were aware of it and did initialization first. And it also may not fail, which was also a problem, because if you use static initializers, then it obviously doesn't work. And this obviously required ABI changes to glibc, and this was another no-go. We had other approaches like a RCU tree, where you have the scaling, but then you add everything to a RCU tree. While this worked very nicely, it had problems because while adding to a tree, you need to rotate all the members. And for simple performance testing, adding and removing, this was like a huge bottleneck, so it didn't work at all. However, from all those lessons, we did learn something. and then we started again. And this time we came up with a completely different strategy. So we started having the main Vutex hash bucket structure per task. And we came up with, instead of allocating it once for a lifetime, we decided to scale it based on the amount of threads. Because simply if you have multiple threads, you may need multiple mutexes that can collide or be locked simultaneously, which are independent of each other. And for this one, we came up with RCU ref. This is also a more or less newer thing, which is slightly more performant than the other performance counters, KREF, for instance, simply because it does not compare against 0 for an increment. It can simply increment always, and it simply looks at the result that came back, like where is the counter, to determine if the reference was acquired or not. And this works within the RCU region. So this is like the lifetime guarantee we have. And so both those two things were working well. And the only point we had is that we have to resize the tree because we scale on the amount of threads that are available, which means if we acquire one a hash bucket struct which is too small and acquire a larger one because we now have like 64 threads, then we need to replace all the current waiters from one hash bucket structure to another. And this worked well. And we also had RCU in two places, like one for the lifetime guarantees of the hash structure and the other one for the lifetime of the acquirement of the counter. And unfortunately, there were micro benchmarks which showed that this was really a performance degradation, something like perf benchmark, which simply does benchmark the hashing part. And you could argue that this isn't a real use case because it's simply benchmarking after the work, the slow path. However, once it was in, Chris Mason reported that he had a benchmark which was basically formed after a real-world load from Facebook. So this micro benchmark argument no longer worked. And the whole thing was marked as broken for 6.16. However, it wasn't over because all the work that we put into it was there, and it was allowed to make a different change. And instead, using the RCU ref as a global counter, as a global reference counter, we were able to replace it with per-CPU counters. So Peter Zylstra came up with this because it was a similar logic that we have in per-CPU reader-writer semaphores. So in CPU reader-writer semaphores, the logic is that you can acquire a reader lock, which is accounted per CPU logic. So the other CPUs are not suffering from this. And once the write logic is acquired, it switches to global counters. And then it goes on when all the readers are gone. Here we have a similar logic. Basically, we have the per CPU counter and use all the RCU lifetime guarantees we had before. And at the time we need to resize and basically allocate a new structure. We switch to global counters, which were slow, but then we only need those for the time of the resizing. Once that is done, we go on and switch over to the CPU counter again. So this is basically the logic that we have as of today. After initialization, we use the CPU counter. And once we need the atomic counter, we wait a grace period before we can switch over it. And this grace period simply is there to make sure everyone saw the global pointer for the structure and the part that we use the CPU counter. And once the RCU period is over, then what we do is we switch to the global atomic counter, which means we go over each CPU counter and add it up to the atomic counter. And ideally, we end up with 0. because there is no reader or user of the hash structure. If there is, we just leave it there and wait until the last one releases its counter, and then it falls down to 0. And after that, once it hits 0, the next user of the futex operation will be forced to perform the resize operation. And this work apparently released it all. And this actually enabled groundwork for another optimization we have. So for instance, on NUMA, people complained, especially from the high performance department, that we have the huge struct for the hash bucket, which is system global, which is interleave over all the futex nodes randomly. So we never know which node is covering which part of the structure. So it may be like the current NUMA node, it may be a different one. And for performance reasons, which they can measure, they preferred obviously the local one. And with this optimization, and with the previous work we already had in 6.7, because until then we had like one big futex syscall, which was covering all, like futex wait or wake or reqpi or even logpi was all one futex call for everything. And in 6.7 we had a different, I don't know what it was in the beginning, but this we took the opportunity to split it all out. So instead using futex syscall with a futex wait opcode, we now have an explicit futex wait for it. And this syscall has the benefit that it allows 2 new flags like the NUMA or the MPOL. And this in turn makes it possible to do something like this. So the URL is where the value that we want to have. And after that, you can have the NUMA value, which specifies which NUMA node to use. And if you use no NUMA node, then this is like what we have right now. It uses a random node and writes back its value, but it still uses a random node which is made based on the hash. Additionally, you can specify as an opcode to use a memory policy. So if this is utilized by the libnuma, the futex code can query it. And then it makes sense to query it once and save it for later. And this means that the big hash that was allocated interleave over all the nodes is now allocated specifically on each node and base of the upper bits of the hash. Or if this is specified by the caller, we can specify the node on which it has to acquire its data structures. Now, another thing. We have lazy preempt since 6.13, which was, I think, earlier this year. We had it in RT for quite some time, basically to cover the part where we acquire logs which are sleeping, and we don't want that other users run on the same log again while we have it acquired. Non-RT doesn't have this problem because they disable preemption, which indeed means they run as long as the spin log is acquired. So lazy preempt help with RT to more or less deal with the same thing by basically delaying the need to reset from non-RT task until the time the log is delayed. The implementation that will mainline is slightly different, and it basically means that we don't schedule right away, but delay to the return to user land, which is kind of like run to completion. So all the resources that were acquired in kernel are already released, and then we can return to user land after a context switch, which is more efficient that way. But if this does not happen because the code remains in kernel for a longer time, then the herd stick will make sure the context switch happens eventually before taking ages. Initially implemented for x86 and all the architectures that support generic entry-exit, manage it very easy to implement it for things like RISC-V or long arch, because the only needed bit was simply to require the need reset lazy bit, and this was like a one-liner. ARM64 and PowerPC required a little bit more work because they do their own entry-exit. The performance with this one is close to voluntary, which means this is what all the distros use by default. And with this, it was convincible for Debian, for instance, to switch over to lazy preempt instead. And the plan is, as far as I'm aware, to switch the default to lazy preempt after this year's LTS kernel. And there was once a plan to get rid of conresket, because with lazy preempt, conresket is basically a knob, like in the preemptible context. But since we have the other architectures which don't work well with preemption, I'm afraid we will have to stick with it for a longer while. But the idea is to switch over to it as a default preemption model if nothing is specified. So with this one, we had a building block for a new invention. This is currently in the works. So basically, userland wants to delay scheduling. And the only reason they want to have it is for user space pin locks. And this department is filled by data space people. So what they want to have is a spin lock in userland where they acquire it, and they don't want to be preempted, simply because they have this small critical section, and after they released it, they would like the preemption to take place, not earlier, because otherwise the other thread will spin on the acquired lock, and this is not what they want, because this is simply wasting resources. So there was a proposal in 2014, which was leading nowhere. Then Stephen Rostedt tried it in 23. On top of the lazy preempt bits we had back then in RT, which were looking like this is what ends up in upstream. Then there was a different proposal, again on top of lazy preempt 24 and 25 by someone else. And then Stephen woke up again and said, hey, I didn't try it for 2 years. Now I need to try it again. Yeah. Thomas said back then that he's not looking into it because the other people should be able to solve it, right? This year, however, he started working on it. And I don't know why exactly, but he made the review of the last one from the Oracle guy. And by the time he made the review, he also made how it should be done. And then he had basically version 0. Then he worked intermediately and fixed a few of the review comments, and he had to rework RSEC, and not entirely, but in large pieces, which was mostly stalling the work on that one. The thing is that the swing bench, which was used by the database people, reported an improvement of roughly 23% of the user space pin locks. And Netflix set a different global log benchmark, which also showed improvement based on it. So user space pin lock is a thing now. It's not merged yet, but I think it should be part of this merge window, which is now. And this is what the user space code would look like, more or less. So the first few lines is basically RSEC specific to register it, and then enable the slice extension as we have it now. And then userland needs to simply request the not scheduling part by simply writing a 1, and then the critical section can take place. And kernel will try to avoid switching, scheduling. And once the critical section is over, then it writes a 0 back. At this point, the variable should be 1. If it's 0 after a readback, then it means the kernel did not grant it, or granted and revoke it afterwards. And if the kernel granted, then it writes a granted into a 1 into the granted variable. And the userland should then honor this and perform a voluntary scheduling part. And if userland revokes and does not follow the protocol, then the health stick that we have for lazy preempt anyway will force the scheduling. And then the scheduler will see that this task overtook quite substantially and will punish it later on. So there is no win if the protocol isn't followed as we should have. Next piece, we have work queues. And most people are aware of it, and the details are always those things that byte want. So scheduled work goes to work queue on the system work queue, which is the global one. And queue work goes to queue work on, which specifies CPU unbound. And the question is, where can this work queue be scheduled? And any ideas? a different hint to make you go wrong is it equivalent to scheduled delayed work? A scheduled delayed work is basically the same as scheduled work, with the difference that it wraps a timer, arms it, and waits. And then after the timer fires, it does exactly scheduled work. So is it the same or is it not the same? It is not the same. The thing is, queue work by default enqueues on current CPU. If the work queue that it should be run on, like system work queue in this case, is not allocated with unbound CPU. So the fact that it was passing work CPU unbound is nothing to say. It is, yeah. It is how the API involved. And if you use, which means queue work will always inquire the work item on the local CPU, and the work item must run on the local CPU. They will know the scheduler is not allowed to move the task to a different CPU, period. And this is how it works. Now, the delayed work queue arms a timer first, and the timer is either taking the no hertz mask into account, or it uses the add timer global. And add timer global has, if it comes to no hertz and the CPU goes idle for a few hertz ticks, then the timer is not necessarily expired by the current CPU it was enqueued, but maybe by a sibling CPU which takes over in that case. So the CPU that goes idle can remain idle for longer periods of time and not be bothered by the timer that can be run globally. Which means in this case, it will not expire on the CPU it was asked for. So you could argue that is a difference, and you should not have this difference there. However, after I proposed it to upstream, upstream was not convinced. And on isolated CPUs, we don't like it mostly. Non-isolated CPUs is nobody cares, because it will run and it will run anywhere or anyway, and it's okay. However, if we have isolated CPUs, the problem is that we might have a syscall which then schedules a work, which is run on the same CPU, and the isolated work is delayed. And this is not what we wanted. The second thing is, if you run RT with on non-RT, but you use RT priorities, and the priority is higher, then the work queue will be delayed, maybe indefinitely, if the userland thread works entirely. And since upstream considered this as an ABI and it has to remain as it is, Marco started refactoring the kernel tree. So what we have now is a mix, which is in the way to be cleaned up. So what we have is scheduled work is now queuing on system per CPU work queue, which is an explicit work, which means it has to run on this CPU. So it's not as hidden as it was before, I hope. And system default work queue is now the default unbound work queue. And Marco makes his way and moves all the users to one of those two. The long-term plan is to remove what we have now, the work queue, the unbound work queue, and the unbound flag, and make the unbound case the default one, and everyone else that needs explicitly a per CPU work queue can make this request explicitly. So this is still work in progress, while we have bits merged of it. Now, my last and final one is we made our way to documentation, and we submitted bits of it, and it ends up in the current tree as a previous release, I think. What we covered are parts like the difference between non-RT and RT. The most obvious part is that we have spinning spin locks, and those behave slightly different. But there are still other parts like timers are slightly different and how they expire. We have IRQ work that is different, and so on. So I took a list and tried to document as much as I remember and put it all down. I also made a list of items that new architectures have to cover. And I had a pretty long list back in the years ago, but with all the generic rework in the kernel, the list got shorter and shorter. And in the out of tree patch, we have a handful of RT architectures. And now, while we got it all upstream, we got RISC-V and what was the other one? Long Arch. I guess Long Arch. And they got it mostly for free because all the RT bits were covered by the generic infrastructure code. And yeah, we have still bits pending, either on the list or in the working. We try to extend it where we can. I think I covered it all by now. Any questions to either of those topics I brought up so far?
Any questions, or are we at the end of the day? It's not. Let's thank the speaker.
Thank you.
It's a big pile of work.
Yeah.